Hey, good morning everyone. Am I audible and visible to you? Yeah, I think we are live. Hey everyone, good morning. Welcome back again. So I hope you had a learning experience yesterday with 100 most predictable or probable problems which we have targeted yesterday from 11th class track for this year NEET. Okay. Now today's target is, in a similar way, we are going to target a lot more problems from class 12th. Before we start our journey, I would like to discuss a bit about the weightage NCERT part-wise with you. So overall guys, we have 4 NCERTs, 2 of class 11th and 2 of class 12th. Like part 1, part 2 in 11th class and part 1, part 2 in 12th class. Out of the 4 NCERT books, the weightage of NCERT part 1 12th class, NCERT part 1 12th class, that means electrodynamics, is maximum. Which means even if I talk about the last year, that is NEET 2024, out of the total questions, 17 to 18 problems came from NCERT part 1 of class 12th. Now why I'm saying 17 or 18, because if you remember there was or if you know that there was a problem in last year which you might have seen in your preparation, that a problem was based on the combination of diode as well as Wheatstone bridge. So if you consider that particular problem to be from current electricity, our total count of the problems from NCERT part 1 class 12th electrodynamics is 18. And if you consider being, dealing with diode, it to be a part of semiconductors, the count will be 17. Still taking the maximum weightage out of all the 4 NCERTs. So today, while taking our discussion ahead, you must be having some weightage criteria in your mind, and I have selected the problems in such a way that if these particular problems are not coming, then there is a high chance that their slight modified models will be coming. So yesterday I have also discussed a lot of modified models attached to a particular problem in the mechanics problems. Today we are going to have a same kind of, or in a better way, we will try to understand the modifications of electrodynamics problems also. Okay, followed by optics and modern physics indeed. All right, so chaliye, without taking a lot of time, let's start our discussion. So chapter wise I have taken problems. So we'll go in the NCERT sequence only, like first of all electrostatics, then current electricity, magnetics, magnetism, EMI, AC and EM waves, and then followed by the book 2, that is optics and modern physics. So the first problem in front of us is from electrostatics. The question says, and this is already a previous year question, but one of the mostly done mistakes by the students. So the question is, 2 point charges Q and minus 3Q are placed certain distance apart. So what did I understand? Q, like plus Q, and minus 3Q are placed a certain distance apart. If the electric field at the location of Q, so if I am the charge and you are trying to get the electric field at my location, then that will not be because of me. That will be because of the other charge or neighboring charge, which means if they say that electric field at the location of Q, that will be due to this minus 3Q. This will be behaving as source, and then you can keep your pen at plus Q and you can say because of minus 3Q, the electric field will be towards it. Because of negative charge, this electric field will be towards it, and this electric field E vector is basically equal to K into 3Q. And let us suppose the separation between them is R. Let us suppose the separation between them placed a certain distance apart, say it is R. Okay, so that will be K into mod of charge, that is 3Q by R square, and it is in which direction? You can call it towards right, or you can call it I cap. Okay, so for keeping the things easy, let me write it towards right. Okay, now what they are telling is, what they are asking basically, then that at the location of minus 3Q. So if the electric field at the location of plus Q due to minus 3Q is this much, then what will be the electric field at the location of minus 3Q? Naturally that will be due to plus Q. And understand, don't do this, sir, for every action there is an equal and opposite reaction. No, so it will be exactly opposite to this. No, It's not the right thing, because whenever you say by Newton's third law, for every action there is an equal and opposite reaction. Their action and reaction are forces, and here we are not dealing with forces, we are dealing with the fields. So what I can say here, suppose I draw the diagram again, this plus q and this minus 3q, and the separation between them is r. Now you are interested in the electric field at the location of minus 3q. So at the location of minus 3q, which means this is going to behave as source charge. This is going to behave as a source charge, and you have to keep your pen at minus 3q. And you will see, sir, because source charge is positive, the field will be away from it. The field will be away from it, and let us call it E nu. So here E nu will be equal to, K. The magnitude of source charge is Q by R square, and that is also coincidentally towards right. Why the earlier case the electric field was right? Because negative charge will have the electric field directed towards it, and positive charge will have electric field directed away from it. So this is KQ by R square towards right. See, now examiner is giving you the 4 options so that you can express the new electric field in the terms of previous one. So KQ by R square is the magnitude of new electric field, whereas K3Q by R square was the magnitude of old electric field. So I will say this is 3 times, this is single time. So can I write this new one as one third of the previous one in terms of magnitude? Also, its direction is also towards right. So you will say these are in same directions. So if these are in same directions, means you can directly write this vector as E vector by 3. If the direction would have been opposite, then I would have kept a minus sign. I would have put a minus sign over here, okay, to show that both the vectors are opposite. But here in this particular question, both the vectors came out to be same, in same direction. That's why I'm not writing this minus here. So the correct option is E vector by 3. Option C, E vector by 3. I hope that's clear. The notes will be shared to you. Those will be attached in the description of this video after the marathon session is over. But meanwhile, if you want to take the screenshot, you can keep taking the screenshots and also share it with your friends. These will be good for revising. You can take that. So there is a doubt in the chat, sir, how many similar questions from these 100 questions can we expect in NEET? So the answer is, if you are a lucky one, then it may happen that, a lot means the total weightage of 12th class will be surely related to these problems. I should not say that, exactly these questions you will get, but by the end of the marathon session, you will realize that every model you can think of regarding the NEET exam is somehow associated, or in fact, I would say very closely related to the problems we are going to discuss today. All right, so let's be hopeful and be, sincerely try to understand the things. Problem 1 is done. Problem 2. In a region, electric field depends on the x-axis as E equals to E naught x square, and the electric field is directed along the x-axis. I hope the picture is clear. There is a cube of edge A as shown in the figure. This is inspired from NCERT solved example. Related to NCERT solved example. If you see the last 2-3 solved examples of NCERT, I'm not mentioning the number because till now few students are referring the old NCERT and few are referring the new one. So you just see last 2-3 solved examples of chapter 1, electric charges and fields. You'll find a similar problem there. Okay, so there also the electric field exists in x-axis and varies with x coordinate. They ask you the total flux linked as well as the total charge. So Gauss theorem we can use. So what they are saying is, find the charge enclosed in that cube. Find the charge enclosed in that cube. So first of all, how many faces does a cube have? A cube is having 6 faces. I'll mention all those 6 faces clearly to you. These top and bottom will have the area vector like this. Okay. these front and back faces, will have area vector in front and will have area vector in back, but the electric field throughout is existing in x-axis. So if electric field's direction is like this, so you will realize that for all the four faces I have mentioned till now, electric field and area vector are perpendicular to each other. Or in other words, electric field lines are passing parallel to these four surfaces. So there will be no flux linked to these four surfaces. But now let us check for the remaining two. If you check for this surface, its surface area vector or area vector is outside and electric field is going from left to right, area vector is towards right, outside. So area vector is towards left, electric field is going from left to right. So the angle between them is 180 degrees. Flux, or you can say inward flux here, is going to be negative. So flux on the left surface is going to be negative. Four faces, top, bottom, front, back, flux linked is 0. Flux through the left surface is negative as cos 180 degrees will come, or inward flux. Mathematically you will say cos 180 degree will come in the formula, which is -1, or you can say inward flux, cross flux, inward flux. Just let me write it as influx. And similarly, if you consider this surface, right surface, here the surface area vector is like this, which is parallel to electric field vector. If it is parallel to electric field vector, I will say flux through the right surface will be positive. The reason for that is in the formula, you can say cos 0 will come, or logically you can say it is outward flux. So inward flux can be taken as negative, outward flux should be taken as positive. Now if you see that carefully, total flux, if I wish to calculate, so here I'll calculate the total flux, finite, that will be equal to, there will be a negative flux here. Now what will be the coordinate of the left surface? See, the coordinate of the x coordinate of the left surface is 2a, and the x coordinate of the right surface, I'll draw it for you. X coordinate for the left surface is 2a, which is also mentioned in the diagram. I'm mentioning it again. X coordinate of the right surface is 2a plus a, 3a, and how the electric field varies is E is equal to E naught x square, which means the left flux, which you are supposed to write it as negative over here, so that is minus of electric field into area. So electric field is E naught x square, x coordinate was 2a square into area. It's a cube, so one face will be a square and its area is basically a square, plus a positive flux, See, left surface is negative, this is negative, and right surface ke liye it would be positive of E naught into x square. The x coordinate will be 3a. Its square, see, it was field and then area, like this. So what you got is minus of 4 E naught a to the power 4 plus 9 E naught a to the power 4. 9 minus 4 is 5 E naught a to the power 4. And by Gauss theorem, this net flux can be written as Q enclosed by epsilon naught. That simply means Q enclosed will be given by 5 epsilon naught E naught a to the power 4. 5 epsilon naught E naught a to the power 4. So the correct option is option C, 5 epsilon naught E naught a to the power 4. Understood now? And since it is directly related to the NCERT model, definitely there is a high chance to get this type of problem in the exam. You can take the screenshot. Okay, chalo, let's move ahead. Yeah, an electric dipole is placed at a distance of 2 centimeter. So that's the JEE PYQ of this year January attempt. So and the problem is quite conceptual. So for practicing the NEET exam, or you can say for preparing for the NEET exam, and since the board is also same to design the paper, I would suggest you to go through the JEE PYQs which are conceptual. So although majority of them in today's session I have brought, so I'm not telling you to do additionally anything, but definitely whatever we are preparing today, you must be revising it at least twice. Okay, for revision the notes will be there, but you can also see the video once again. If explaining to you benefits you, increases your conceptual depth, then definitely you can rewatch this video, and make sure you share it with your friends too. An electric dipole is placed at a distance of 2 cm from an infinite plane sheet having positive charge density. If it's a positive charge density, we can say the electric field will be like this, and its value will be sigma by 2 epsilon naught, and it is distance independent. Distance independent, that is, you will say a uniform field. It is a uniform field, that is uniform. Now, so if it's a uniform field, this implies the net force acting on the dipole is 0. Net force acting on the dipole is 0. Next is, if you see the option, they are talking about the net force acting on the dipole, as well as net torque acting on the dipole, as well as the potential energy of the dipole. Okay, so we'll talk about all three. Field is uniform. Whenever an electric dipole is kept in a uniform field, the net force acting on it is 0. Now, let us talk about the torque. Electric dipole moment is directed from negative to positive, like this. And can you see electric field and electric dipole moment are parallel to each other? If they are parallel to each other, that is theta is equal to 0 degrees. If theta is equal to 0 degrees, number one, torque vector will be equal to Pe sin theta n cap. Or you can simply say, let us talk about the magnitude of torque. Tau will be equal to Pe sin theta, because theta is 0 degrees. So Pe sin theta, tau is 0. Number two, potential energy U, that will be minus Pe cos theta. So that will be minus Pe cos 0 degrees minus Pe. Potential energy is minimum, and we call this situation as stable equilibrium. Parallel electric dipole moment and electric field, stable equilibrium. Anti-parallel electric dipole moment and electric field opposite to each other, unstable equilibrium, potential energy will be maximum. And if the dipole moment and electric field are perpendicular to each other, in that case the torque is maximum. Torque is maximum, Pe sin 90, that is maximum, and it is not any kind of equilibrium. Okay, the dipole will start rotating. I hope that's clear. You can keep taking the screenshots meanwhile. Let's move ahead. Next is 2-point charges minus 4 microcoulomb and plus 4 microcoulomb constituting an electric dipole, and their coordinates are given. See, charges are also given, equal and opposite, and their location coordinates are also given, and they are placed along the x-axis, because y coordinate and z coordinates are 0, but the x coordinates are also in centimeters to take care of the units. Charges we have microcoulomb, here we have centimeters, and all the 4 options, whatever they are asking there, that is in millijoule. So it can be a game of units also. In a uniform field strength is given to you. The work done on the dipole in rotating it from the equilibrium through 180 degree. So rotating it from the equilibrium through 180 degree means, if you are doing some work, which means initial equilibrium would have been stable equilibrium. Initial equilibrium would have been stable equilibrium, and rotating through 180 degrees means what you will achieve here is unstable equilibrium. I repeat, initially you would have, the dipole would have been aligned in accordance with the external electric field so as to have the maximum stability. So initial equilibrium is stable equilibrium. Now you are supposed to rotate it by 180 degrees, means now the equilibrium will be unstable equilibrium. So what they are asking you, the work required to be done. So if they ask work done, then by default it means work done by external force. Why I have emphasized on that? Because if they ask work done by electrostatic force, that is minus of change in potential energy. But if they ask work done or work done by external force, that is change in potential energy. So I will say here, work done by external force, that will be equal to change in potential energy. So that is UF minus UI. Okay, UF minus UI. Finally, you are unstable equilibrium means minus PE cos 180 degrees. Initially, you were in stable equilibrium means minus PE cos 0 degrees. So it is cos 180 is minus 1, minus minus will become plus, minus minus this will become plus PE, and cos 0 is 1 only. So what you got is 2 PE, or what you can write is it as 2 into Q into distance between them into E, external electric field. So that will be equal to, this implies that will be equal to 2, charge is 4 microcoulomb, magnitude of any charge, so 4 into 10 to the power minus 6. The length is the total separation between them. So one is placed at minus 9, another one is placed at 9. So I'm sure you can understand that the total separation between them is 18 centimeters. See here, separation or length of dipole will be equal to 18 centimeters. So I'll put it over here, 18 into 10 to the power minus 2. And external electric field already given in SI units, Newton per coulomb or volt per meter, those are the SI units. So that is 10 to the power 4. And hence you can solve it easily. Alright. So this is the situation. I hope I can leave this small basic calculation for you. Quickly take the screenshot, then we will move ahead. Alright. Next is two metal spheres, one of radius r and the other of radius 2r respectively have the same surface charge density. This is a question which is based on charge distribution. So I would like to share the charge distribution rules with you. Charge distribution rules for same potential, for equipotential surfaces or same potential bodies. So I will simply say the rules are actually, I want you to remember two things, that Q is directly proportional to C, and C, capacitance for a spherical capacitor, is directly proportional to R. So you can say Q is directly proportional to R. So charge will be distributed, in comparison to, directly in comparison to the radius. Number 2, sigma is equal to Q by, like proportional to Q by R square. Sigma is proportional to Q by R square, where Q is directly proportional to R. This implies sigma is inversely proportional to R. Okay, sigma is inversely proportional to R. These are the charge distribution rules, and I'm going to take help of this one. How? Now see, the radius is R and 2R. So final sigma is inversely proportional to R. This implies sigma 1 by sigma 2 should be R2 by R1, should be 2R by R. So that should be 2:1. That should be 2:1. This is going to be the situation. Now let us try to find out the value of, sigma 1 by sigma 2. Search for this. Okay. We are not solving this problem because the solution of this problem will go very long, but the moment you will try to apply the charge distribution rule, orally you can solve this problem. See how? Sigma 1 by sigma 2. This by this, if you will do 5 by 2 by 5 by 3, 5 will be cancelled, and denominator 3 will become the numerator. So that's going to be 3 by 2. Here 5 will be cancelled, that is 6 by 3 or 2 by 1. Here it is 2 by 6, denominator will become numerator, 2 by 6 or 1 by 3, and here it will be 6 by 2 or 3 by 1. But what you were searching for is 2:1, and hence second option is correct. So these are the charge distribution rules. This is already a PYQ. Today we have discussed on the basis of sigma. The same thing can come on the basis of charge. Okay, so take a screenshot. All right, for the revision I'm telling you. Let's move on to the next one. The electric potential V is given as a function of distance x by V is equal to, as a function given to you, the electric field they are asking you at x equals to something. So let me write that. So here what we have is V equals to 5x square plus 10x minus 9, plus 10x minus 9. What they are asking you is electric field E vector. I hope you remember it is minus dV by dx. You will take normal differentiation if it is a single value function. If it is a multiple variable function, you will go ahead with partial differentiation. But partial differentiation is not so common for NEET. Normal differentiation is there. So see, minus of, if I have to differentiate this, so I will say 5x square differentiation is 10x plus 10x differentiation is 1 minus 0, constant derivative is 0. And if you are going to multiply with this minus, so it will be minus 10x minus 10. Okay, so they are asking you electric field at x equals to 1. See, electric field at x equals to 1. So what we can get here, electric field at x equals to 1, we can get, just put here minus 10 into 1 minus 10, and hence the final answer is minus 20, which has been already highlighted here. All right, so we knew the answer, but we just saw the process of doing it. I hope the process is very easy. Let's go. Next is a charge plus q is placed at the origin. This is also this year January's JEE, this year JEE PYQ JEE question. So we are expecting this type of problem because this type of model has already come in NEET once. If you will refer to the NEET PYQs, you will realize that. So instead of taking exactly the same NEET problem again, I have taken this problem which has come in JEE and has a probability to come in NEET. So a charge plus q is placed at the origin of xy axis as shown in the figure. The work done in taking a charge q from point A to B along the straight line. So you will say the from A to B. So this was your initial position and this was your final position. A charge plus q is kept at the origin. A charge plus q is kept at the origin, and the work done in moving a capital Q charge from A to B they are asking. So I said few minutes back, I told you that if they are not mentioning whose work done, then it is not electric field or electrostatic force work done. Nope, it is external force work done. So I'm writing it here for you. Work done by electrostatic force. Electrostatic, that is minus of change in potential energy, that is Ui minus Uf. And work done by external force, which is also by default, which is also, if nothing is mentioned, then also you should take it like this, that is Uf minus Ui. Few minutes back we have used this concept for the dipole problem. Now we'll do the same again. So delta, the work done will be equal to final potential energy. Finally it was here, okay. So finally it is here, K capital Q small q by final separation between them is B minus K capital Q small q by initial separation between them is A. Very simple here. Q can be taken common, K can be taken common and can be written as 4 pi epsilon naught here, 1 by B minus 1 by A, or you can write it as, see what you can write, here I am writing it, or QQ by 4 pi epsilon naught, that's A minus B by AB, A minus B by AB, see. So QQ by 4 pi epsilon naught, A minus B by AB, I think first option is the actual answer. Okay, I hope that's easy. Let's go. Next is, if radius of a hollow metallic sphere is R. If radius of a hollow metallic sphere is R, if the potential difference between its surface and at a point at a distance 3r from it, they are not telling the potential, they are telling the potential difference. See, this is not the potential. This is not potential. This is potential difference. Okay, potential difference. Although we already know the answer, but let us follow the procedure. It's a very nice problem. Then the electric field intensity at a distance 3r from its center. So what I can write is, given for us that potential difference between the surface minus potential difference, say at a point P, which is at a distance of r is equal to 3r, this is given as V. So potential at the surface or center, if it's a metallic sphere, potential at surface, potential at center and potential at any inside point, it is given by kq by radius. Kq by radius minus, this will be kq by 3r, that is equal to V. So 1 minus 1 by 3 is 2 by 3, I suppose. 2 by 3 kq by r. 2 by 3 kq by r is equal to V, or you can say from here kq value, which I will be needing very soon, kq value can be written as 3VR by 2. Just keep it aside. Kq value is 3VR by 2. Now what they are asking? Now they are asking you the value of electric field at this P point. So electric field magnitude at this P point where R is equal to 3R by standard Coulomb's law formula, that can be written as kq by 3R ka square. kq by 3R square. So kq value you can keep it like 1 by 3R square is basically 1 by 9R square. And kq value you can keep it over there 3VR by 2. See, 3VR by 2. So 1R will be cancelled. 3 will cancel this 9 at 3 times. Remaining 3 into 2 is 6. So that will be equal to V by 6R. And see, the result has been already marked. Alright. I think we are done. Let's go on. Next is 3 condensers are connected as shown in series. If the insulated plate of C1 is at 45 volts, see, 3 capacitors are in series, one end is at 45 volt and another end is at 0 volt. Find the potential difference between the plates of C2. Find the potential difference between the plates of C2 they are asking. Okay. So I think they are in series. If you will realize Q is equal to CVHL, being in series, Q is equal to CVHL, being in series, this Q is same. Okay. This Q is same. This implies I can write that VHL drop is inversely proportional to C. If it is inversely proportional, so for 2 capacitors, I can also do it directly by the equations and all, but I want you to understand the charge distribution as well as the voltage distribution. So for 2 capacitors in series, since it is inversely proportional, we will distribute the potential difference in inverse ratio of the capacitance. So we will say V1 will be equal to opposite capacitance C2 into total V total by C1 plus C2. And similarly, V2 will be opposite capacitance C1 into V total by V1 plus C1 plus C2. C1 plus C2. Now, but sir, here you are writing it for 2 capacitors. Here you are writing it for 2 capacitors. But in the picture, there are 3 capacitors. Then what to do? It's okay. If you will combine this 4 microfarad and this 4 microfarad, the equivalent will be 2 microfarad in series. Okay, the equivalent will be 2 microfarad in series. Now, if you are writing the V across 7 microfarad, then that will be equal to the opposite capacitance. What is the opposite capacitance? The series combination of these two, that is 2 into V total. Total potential difference is 45 minus 0 by sum of the capacitance. Sum of the capacitance is 7 plus 2, 7 plus 2. Alright. So you will have 45 minus 0, that's 45 into 2, 90 by 7 plus 2, 9. 90 by 9, final answer should be 10 volts. Okay. So I wanted to share this, just a basic rule of physics, which we have used yesterday also. We keep using that in different chapters and topics, and I have emphasized on it right now also. Listen to my words very, very carefully. If we get a directly proportional relationship, then for any 2 elements, we can divide the physical quantity in the direct ratio. If we get a directly proportional relationship, then we can distribute the total physical quantity in 2 elements in the direct ratio. And if we get in that case, that will be the same value of capacitance. But in case of inverse relationship, definitely we will distribute it in inverse ratio, which means every time we will be taking the opposite value. Alright. Right now I am not extending this discussion on this problem, but very soon we will find the similar problems here. I hope you are comfortable with this. Next. In the circuit, if the energy of 8 microfarad condenser is E, the energy of 4 microfarad condenser is. So here, capacitors problems these years are common, in which energy loss problems in capacitors are quite common. So this is also a similar one. In the circuit, if the energy of 8 microfarad condenser is E, the energy of the 4 microfarad condenser is. So I will say that suppose if I am interested in taking the resultant of these two, if I am interested in taking the resultant of these two, 20 and 4, will it be 24 microfarads? Yes, 24 microfarad. And just now I have told you that the voltage distribution is in inverse relation. Voltage distribution is in inverse relation. So if you have this 8 microfarads and you have 24 microfarad and these are in series, okay? These are in series combination. So can you see that capacitance value from here to here, capacitance value is getting 3 times. This implies VHL, which is inversely proportional to C in series. Just now we have done in the last slide, that will naturally become 1 by 3 times. 1 by 3 times. So that is, say, potential drop across 8 microfarad is V0. Suppose, then potential drop across 24 microfarad will be equal to, potential drop across 24 microfarad will be equal to V0 by 3. That's what I said. If capacitance becomes thrice, then the potential drop will become 1 by 3. Potential drop will become 1 by 3. So how to deal with that? So can I say here, the energy stored in 8 microfarad capacitor is E. Energy stored formula is 3 formula we have, Q square by 2C, half CV square and Q into V by 2. So let's Q into V by 2. Okay ji? So now what I am telling you is that I'll be using this formula of half CV square. So E will be equal to half in 8 microfarad. So it is 8 into V square and the voltage there is V0. That's what we have assumed. Then E dash across 4 microfarad. That will be equal to half. This is 4 and this is V0 by 3 square. By in series combination, the capacitance value are given to you. So in series combination, we have distributed the voltage. Let us divide it. So if you are going to divide it, what you will get here? If you are going to divide, you will get E by E dash will be equal to, this half and half will be cancelled. This 8 by 4 will be 2 and this is V0 square by V0 by 3 ka square, means it is V0 square by 9. Denominator will become the numerator. It is 9. So I guess E dash is equal to E by 18. From here we are getting E dash is equal to E by 18. You please keep checking the calculations also. For majority of problems, I am not taking the answer key because the problems, NEET problems are always very easy here. And we have to train ourselves for the common mistakes. So wherever there is a chance that majority of students do the mistake, or the mistake is quite probable for this year also, I'll keep telling you. Alright, you can take the screenshot. Capacitor problems and energy related capacitor problems are quite common. So finally, with these 10 problems, our discussion of probable or must do electrostatic problems is completed. Now we will start with another chapter, that is current electricity, which in short is the most important chapter of the entire NEET syllabus. Which of the 4 resistances P, Q, R and S generate the greatest amount of heat when a current flows from A to B? When a current flows from A to B, they are asking you the greatest amount. They might ask you the least amount. They might ask you the ascending or descending order. So let us generalize that how to deal with this type of problems. So now what I do is, see, I will say the upper arm resistance is 2 ohm plus 4 ohm, 6 ohm. And the lower arm resistance is 2 ohm plus 1 ohm, 3 ohm. Okay. So upper arm resistance is double, twice, 2 times. So if the current is I0, suppose if the current is I0, then definitely in the lower arm where the resistance or opposition is halved, the current will be definitely doubled. So if current will be definitely doubled, it will be 2I0. I repeat, where the resistance is single time, where the resistance is double time, the current is single time. and where the resistance has been halved, naturally the current has to be doubled. The current will be doubled. So in that case, if I have to write the power comparison, so power comparison of P, Q, RSC I'll do here. Power in P, that will be equal to the current flowing in that is I naught square into 2. So that is in short 2 I naught square. Power in Q, so that is I naught square into 4. So that is 4 I naught square. Power in R, that will be 2 I naught square into R resistance, the value is 1. So that is 4 I naught square. And power in S, that is 2 I naught cos square into 2. So that will be 2 square, 4 into 2, 8 I naught square. Okay, 8 I naught square. So now you can choose the maximum and minimum. This value is minimum. This value is maximum. Okay, they have asked you maximum, minimum or maximum, or they can also tell you the ascending, descending order. So here by increasing, decreasing order also you can see that power in P is minimum, and then it is power in Q and power in R, which is coincidentally same, and the maximum power is of S. Okay, very easy. So sometimes regarding the energy or power we can comment on the basis of current, sometimes we can comment on the basis of voltage. I hope that's clear to you. Right, let's move ahead. Next is, consider the following two statements. Now these two statements are given for the universal laws, that is Kirchhoff's laws. So we know Kirchhoff has given two laws. One is KCL, Kirchhoff's current law, and one is KVL, which is Kirchhoff's voltage law. Kirchhoff's current law, we know that it is based on conservation of charge, that charge can neither be created nor be destroyed. So there is no accumulation anywhere of current at any junction. The incoming must always be equal to outgoing in terms of current. Okay. KVL, Kirchhoff's voltage law, it is based on conservation of energy, that the net voltage, net potential drop across a closed loop is always going to be 0. Now see here, Kirchhoff's junction law means KCL follows from the conservation of charge. So that is true. Kirchhoff's loop law means KVL, junction law is also called as KCL, and loop law is also called as KVL. So as I said, KCL is based on conservation of charge and KVL is based on conservation of energy. KVL is based on conservation of energy, KCL is based on conservation of charge, and I think hence here both A and B are correct. Okay, I have taken this problem just to review the concept. It is a standard and very basic problem, but be careful here. Sometimes the problems which are repeated in the exam are similar but not the same. So this problem is so obvious that even if they just change the junction and loop, a good number of students can do the mistake. So be careful which law is based on which fundamental conservation law. Read it completely. Even if you know, even if you have done the problem 10 times before, still before bubbling that in the main exam on the big day this year, you make sure you read the entire question carefully. Alright. Next. The reading of an ideal voltmeter in the circuit shown is, what is so great about ideal voltmeter? It is that internal resistance is infinite. Internal resistance is infinite means, I would say, no current flows through voltmeter. No current flow through voltmeter arm. Through voltmeter arm. Okay. Now, this is 2 volt. This is 2 volt. There is no current flowing. They are just asking you the potential difference. If you see that carefully, that here 30 plus 20 total is 50 ohms, and here also 30 plus 20 total is 50 ohms. So upper arm resistance, lower arm resistance, both are going to be same. So can I say resistance of the upper arm and resistance of the lower arm, both are going to be same, and how much? 20 plus 30, 50 ohms. Current in the upper arm, current in the lower arm, both are going to be, because both arms are in parallel, so the potential difference across both is 2 volt. So that is 2 by 50. 2 by 50 amperes. Okay, I can simplify it, I can write it as 1 by 25 amperes, but let's keep it that way because this is not going to give you your final answer. We are going to move ahead. Let this be point O, let this be point A, and let this be point B. They are asking us the voltmeter reading VA, VB like that. Okay, so can I write here in the upper arm potential difference VO minus VA, basic Ohm's law, VO minus VA is IR, 2 by 50 into R. That R is what in the upper, like between points O and A, it is 20. Now see what you got, 0, 0 got cancelled, you got 2 into 2, 4 by 5 volts. What you are applying is basic Ohm's law. Okay. Now suppose in the lower arm, I do the same process and I write VO minus VB. VO minus VB, the current flowing is again the same, 2 by 50 into the resistance in between is 30. So what you got here is 0, 0 got cancelled, it is 6 by 5 volts. As you can see, this is bigger and this is smaller, and they are not specifying whether they want VA minus VB or VB minus VA. So let us do bigger minus smaller. So bigger minus smaller like this minus, V0 will be cancelled, minus minus here it will be plus, VA minus VB, or you can say VAB, that will be equal to bigger minus smaller, 6 by 5 minus 4 by 5, that is 2 by 5, or now you can simplify it 0.4 volts. Or in other words, you can say if they specify VBA, that tell me VBA, VB minus VA, then that would have been minus of 0.4 volts. Minus of 0.4 volts. So VA minus VB is as of now 0.4. So the correct option is D. I hope you understood the problem. Problem was based on 2-3 things. First basic concept involved here is ideal voltmeter has infinite resistance, so no current flows through the ideal voltmeter arm. Next is that upper arm, lower arm resistance is going to be same and they are in parallel, so the current is also going to be same. And the third step, I have just applied simply the Ohm's law. I hope that's clear. Let's move ahead now. Next is, in the circuit shown below, the readings of the voltmeter and ammeter will be until or unless not mentioned separately, the ammeters and voltmeters are to be taken as ideal. Ideal ammeter, internal resistance is 0. Ideal voltmeter, internal resistance is infinite. Now see these two circuits. Ammeters are ideal. Ideal ammeter, concept kya hai? Concept is ideal ammeter, we will say internal resistance is 0. Short circuit. And short circuit behavior. And ideal voltmeter, internal resistance is infinity. Means what behavior? Open circuit behavior. Now if you see, the basic difference between these two circuits is this 10 ohm resistor. The only difference between these two is this 10 ohm resistor, but anyways this 10 ohm resistor is not entertained. Why it is not entertained, sir? Because it is connected in the voltmeter arm, and voltmeter arm, because of the infinite resistance, does not allow any current to flow. So a resistor without current is not entertained. A resistor will oppose only if the current is flowing through it. No. So what you can say, 10 ohm is not entertained because of as no current flows through voltmeter arm. If there is no current flows through voltmeter arm, okay, so what I can say here, that the only difference between these two circuits was the insertion of 10 ohm, which is not even entertained right now. So there is no practical difference between the two circuits. And if there is no practical difference between the two circuits, both the readings are going to be same. Voltmeter reading is also same and current reading is also same. Understood? Easy enough? NEET problems are going to be easy. In fact, physics NEET problems, I should say, are going to be very easy. It's just that we need to identify, first of all, which are the easy problems for us. In the first scan, for priority is time management and then doing the problems in scanning basis. First scan, do all the easy and moderate problems. Then in the second scan, you should go ahead with the tougher ones or difficult ones. So now, two non-ideal batteries are connected in parallel. Consider the following statements. the equivalent EMF is smaller than either of the two batteries, and the internal resistance equivalent is also smaller. So I'll just write the formula for your better analysis. You can write E equivalent is equal to E1 by R1 plus minus E2 by R2 depending upon supporting polarity or opposing polarity, 1 by R1, but the resistance in the denominator is always added. Okay, and say that suppose R1 and R2 are equal, R1 and R2 are equal, say R1 is equal to R2. Just to simplify this mathematically a bit, so I will say R and here R and R will be cancelled, all R's will be cancelled, and you will be getting E1 plus minus E2 by 2. So anyways, even if it is a plus E1 plus E2 by 2 or it is a minus E1 minus E2 by 2, so if they say the equivalent EMF is smaller than either of the two EMFs, I think if it is a minus, then there is a possibility that it will be lesser than both. But if it is a plus, they are saying two non-ideal batteries, but they are not telling whether the batteries are identical or not. Even if the batteries are identical and it is the case of same polarity, it is E plus E by 2, which is 2E by 2, that means E. So naturally it is not smaller. It can be equal. It can be average value. Average value means if there is a plus sign in between, it is E1 plus E2 by 2. It's the average value kind of. And the property of mathematical averages, normal arithmetic mean is, it is bigger than the smaller value and smaller than the bigger value. It will lie in between. That's why you call it average. Okay. So it clearly shows not necessarily smaller than E1 and E2. Not necessarily smaller than E1 and E2. But if you talk about R equivalent, the R equivalent for parallel combination is R1 R2 by R1 plus R2, and we know that here this R equivalent is less than R2, it is also less than R1. Okay, so equivalent parallel resistance is definitely for sure lesser, but that's not the same thing true. That's not the same thing true in case of EMFs. Okay, G. So that is going to be the situation. I hope you are comfortable with that. Fine. So when they say that it has to be lesser, EMF has to be lesser, then the EMF is smaller than either of the two EMFs, I'll consider it to be false. Not necessarily. The equivalent internal resistance is smaller than either of the two, I'll consider it to be true. I hope that's clear. I've simply used the standard formula and some basic mathematics involved. You can take the screenshot. All right. Right, let's move ahead. Now, the next question is the net current flowing in the given circuit is, you see it's a given circuit, looks very complicated, but if you notice there is a capacitor connected here. This capacitor at steady state behaves, steady state means it is fully charged now. If it is fully charged, it behaves as broken circuit or open circuit. Behaves as broken circuit or open circuit. That is, internal resistance offered by the capacitor is infinite and current through this arm is zero. Current through this arm is zero. There is no current in this arm. So the given circuit will be simplified to, or that will be reduced in this format. This is 2 volt and this is 4 ohm, this is 2 ohm here, this is 3, here it is 6, and now it is 2.5, and then it is broken here, and this arm is 5, and this is 8, and this is 1 and 4. Okay, no? So now if you realize that this portion has been detached from the actual main network, so I will say this will be non-functional. There is no current, there will be no current entering it, because if the current enters it, it cannot come back. No, it is this portion of the network is not connected at 2 points with the main circuit. Okay, so there cannot be any circulating current there. which can come back. And similarly, the 2.5 ohm, if you send the current that way, you cannot take it back. So this 2.5 is also not to be entertained. Fine. So the actual network is available here only. You see 6 and 3 are in parallel. 6 into 3 by 6 plus 3, 18 by 9 is 2 ohm. These are in parallel. I'll do it step by step. These are in parallel. So the answer will be 2 ohms. Okay, 6 into 3 by 6 plus 3. Now this 2 and this 2 are in series. This 2 and this 2 are in series combination. So 2 plus 2 is going to be 4 ohm. 2 plus 2 here is going to be 4 ohms. And this 4 ohm and this 4 ohm. This 4 and this 4 ohm are in, they are in parallel. Okay. This 4 and the other arm 4, these are in parallel. So 4 and 4 in parallel, answer is 2 ohm. So if someone is asking you, tell me the net current through the battery, so that will be 2 volt by 2 ohm, and hence the answer should be 1 amperes. Final answer should be 1 ampere here. You can clearly see that. I think that's okay. First learning, the part of the circuit will, like after the capacitor is connected, because that has been broken, that will not be entertained. And then we have subsequently, like step by step, what we have been doing is series, parallel, like this. That is an easy calculation involved. Let's move ahead. Next is, a wire of resistance R is bent into an equilateral triangle and an identical wire is bent into a square. So it is bent into an equilateral triangle and then it is bent into a square. And remember that the wires are identical. If the wires are identical, means their lengths are going to be same, their resistances are going to be same. If you have divided it into 3 parts, you have got it as R by 3, R by 3 and R by 3. And here you have divided it into 4 parts. So each arm will be R by 4, R by 4, R by 4 and R by 4. Okay, that is the situation. Now, the ratio of resistance between the 2 endpoints, of an edge of the triangle to that of the square, which means you are connecting the battery here. You are interested in the equivalent resistance here like this, and you are interested in the equivalent resistance here. So if you see that carefully, these R3 and R3, like R by 3 and R by 3, I should say 2R by 3 and this R by 3, these are in series and then they are in parallel with this. So R in case of triangle, that will be equal to 2R by 3 in the upper arm and R by 3 in the lower arm. So that is 2R by 3 plus R by 3. Anyways, in the denominator, it's the total resistance of the wire. It is going to be R. So if you see that carefully, the answer is 2 by 9R. 2 by 9R, 2 by 9R, because 1R will be cancelled here. This total R and this 1R will be cancelled. So you will be having 2R by 9. And similarly, if you try to do it for the second one, R, let me write it for triangle. And if I write the same for the square, the required resistance between the across the end of one edge, the upper arm resistance is 3 times R by 4, because those 3 will be in series, and then the lower arm is R by 4, and here it is 3 R by 4 plus R by 4, which is obviously again supposed to be R. So this R and this R will be cancelled, and what you are going to get here is 3 R by 16. 3 R by 16. So if they are asking you the R triangle, like I'll write it here. If they are asking you R triangle by R square, so R triangle is 2R by 9 and R square is 3R by 16. So I think R and R will be cancelled. Denominator will become numerator. 16 into 2, 32 we got, and 9 into 3, 27. So 32 by 27, I guess fourth option is correct. But be careful, like what they are asking, triangle to square or square to triangle. So in the order of the language, they were asking triangle to square. That's why I have done it this way. I hope that's clear. Easy problem again, but good problems these are. Okay. Next is the value of current in the electrical circuit as given below when potential at A is equal to the potential at B. If you say potential at A is equal to potential at B, then definitely there is no current entertained here. And for that matter, here I will say for potential of A to be equal to potential at B and current through the 30 ohm resistance to be 0, can I say it must be a balanced Wheatstone bridge network. We must be having P by Q is equal to R by S. P by Q must be equal to R by S. What is the value of P? That is 10. What is the value of Q here? That is 20. What is the value of R? Yet to be calculated. And what is the value of S? That is 40. Okay, so naturally here R came out to be 20 ohms. R came out as 20 ohms. Here it is 20. Fine. Now what they are asking you, the value of current in the electrical circuit, the outer current they are, the main circuit current they are asking. So can I say this R here is coming out as 20 ohms. Now if you see the upper arm 2 resistors and the upper arm 2 resistors are in series, lower arm 2 resistors are in series, and upper arm and lower arm are in parallel, and there is no current flowing through it. So 20 into 10, that 20 plus 10, that's 30, and here it is 40 plus 20, that's 60. So can I say, if I do it stepwise again, R in the upper arm, that will be, both are in series, 10 plus 20, that is equal to 30. R in the lower arm, that is equal to 20 plus 40, that is equal to 60 ohms. So R net, that will be equal to what? R net you can write it as 30 into 60 by 30 plus 60. 30 into 60 is 1800 by 30 plus 60 is 90. So 0, 0 cancelled. Answer is 20 ohm. So if they are asking you the main current, that will be equal to 40 volts by 20 ohms, and hence the answer is 2 amperes. All right. Easy again. See that, have a look. And I'll be going in a good rhythm today because every student will have a different, pace of learning. Whenever you feel that, you can do it much faster or you need it a bit slower, please use the speed feature of the video on the YouTube, and then you can adjust it according to your convenience. Next is a straight conductor carrying current I splits into two parts as shown in the figure. The radius of the circular loop is R, the total magnetic field at the center of the loop is. So in case of any regular polygon, circle can be treated, as a regular polygon. Regular polygon, equal sides, equilateral, equiangular. Circle can be treated as a regular polygon having n sides where n is very large, where n tends to infinity. Okay, we can call it this way. And now a polygon property, a very important property of magnetics. If current enters, gets divided, and then leaves a uniform regular polygon. Regular polygon you've made by a uniform wire. Uniform regular polygon, then magnetic field at the center of polygon, due to polygon. Magnetic field at the center of polygon due to polygon is supposed to be 0. It is going to be 0. For example, so here the answer is going to be definitely 0. The other examples are, you can say it's a square here. So I will say, suppose the current enters like this, right? I naught. Suppose the current leaves like this. Acha, deliberately you can also ask me, sir, because of the circle at the center of the circle, suppose you say 0, what about the other wires? So these outer wires are also arranged in such a fashion that the P point lies on the axis of the wire. And whenever a point lies on the axis of a straight conductor, the magnetic field there is going to be 0. Okay. So due to polygon at the center of the polygon it is 0 by the property. I am going to give more examples. But in those examples also I'll keep the orientation of the outer wires in such a way that the P point will lie on the axis of the wire. For example, I'll not draw the wires like this. No, because then P point will not be on the axis. I'm drawing the wires like this so that the P point will still be at the axis of the two. This is the P point here. So the P point is still at the axis of the two and it's a square. So due to the polygon, at the center of the polygon, current enters, gets divided and leaves every time it is 0. Another example. Suppose I take it this way. It's again a square. It's again a square here. And this time we are not taking the opposite edges, we might take the adjacent edges like this. Okay, opposite, diagonally opposite and adjacent. This is point P, or else it might be a hexagon, it might be an equilateral triangle. The smallest polygon we know na, the smallest polygon is going to be an equilateral triangle. Alright, smallest regular polygon. Here we will say that we are sending this in such a way that, let me take again, the P point lies on the axis of the conductor, like this. So P point will be the centroid this time. P point will be the centroid. So can I say whenever current enters, gets divided and leaves the regular polygon, then due to the polygon at the center of the polygon, in all such cases, B at P point is going to be 0. Remember this property. Next time you see the configuration, tick mark the answer 0. Provided make sure that there is no magnetic field due to outer wires, because the question contains the polygon as well as the outer wires. If the P point is not lying on the axis of the outer wires, then you are supposed to calculate it separately. Alright. Okay. Chaliye. Let's move on. Every time I'm getting a bit aside when the problem is completed so that you can take the screenshot if required. At steady state, the charge on the capacitor as shown in the figure below, as shown in the circuit below, is the charge on the capacitor. They are talking about the steady state here. So let me zoom it a bit. I think it is still clear for you. Yeah, much clearer hopefully. So at the steady state, there will be no current flowing through it. There will be no current flowing through it. Okay, no current. So can I say the current will be primarily flowing in the lower arm? If it is primarily flowing in the lower arm, so in case of series combination, like if I apply Ohm's law, VHL is equal to I into R, you can see the current is same in series, okay, in both resistors. If it is same in both resistors, I am going to divide the voltage. So VHL is directly proportional to R, therefore V1 same. I told you a few minutes back that when the things are directly proportional, we divide the quantity in the same ratio, but when the things are inversely proportional, we divide the quantity in the inverse ratio. So V1 will be equal to total potential drop VHL into same resistance R1 by R1 plus R2, and you can say V2 will be equal to VHL into same resistance R2 by R1 plus R2. Okay, I'll be using these properties. So now let us talk about the exact problem. The problem is they are talking about the charge on the capacitor, 8 microfarad. So charge is Q is equal to CV, and you need the answer in microcoulombs. So let me just keep the data 8, and it is the potential difference, but the 8 microfarad capacitor is in parallel with 10 ohms. So you need the potential difference across 10 ohms, which by the voltage division rule can be written as total potential difference or EMF 5 into same resistance 10 by sum of resistance 10 plus 15. Okay, total into same by total resistance. So 5 into 10 is 50, by 10 plus 15, 25, 50 by 25 is 2. So 8 into 2, final answer is 16 microcoulombs. Alright, So at steady state, there is no charge, there is no current flowing through the capacitor. The capacitor plates are fully charged. Okay, that full charge or maximum charge is 16 microcoulomb. If someone is asking you the energy, energy stored, that energy stored can be written as half CV square or Q square by 2C. Half CV square. C is 8 microfarad. 8 microfarad, 8 into 10 to the power minus 6 into V square. The voltage across that will be 5 into 10, 50 by 25, that is 2. I mean, what I am trying to say is that 2 volt is getting dropped here and 3 volt is getting dropped here out of the 5. So that is here 2 square, half CV square, or you can say Q square by 2C, 16 into 10 to the power minus 6 ka square by 2 into 8 into 10 to the power minus 6. The above formula is half CV square, the lower formula is Q square by 2C. Alright, chaliye, let's move on to the next one. Given below are two statements, one is labeled as assertion, other one is labeled as reason. An electron in a certain region of uniform magnetic field is moving with constant velocity in a straight line path. It is possible or not? An electron is entering in a uniform magnetic field and it is following a straight line path. Possible if V vector is parallel to B vector or collinear. So in that case, the magnetic force is going to be 0, and which means field is there, but since the electron is moving collinear, parallel or anti-parallel with the magnetic field is there, but it will not experience any magnetic force. And if there is no magnetic force, obviously the path will be undeviated, a straight line path. Alright. Next is the magnetic field in that region is along the direction of velocity of the electron. That is also true. And I think it is the same possibility I am talking about, which means it explains also. So assertion is true, reason is true, as well as reason is an appropriate explanation. Both A and R are true and R is the correct explanation of A, second option. Hope that's easy. Next is, right. An infinite wire has a circular bend of radius A. An infinite wire is there that has a circular bend at radius A and carrying a current I as shown in the figure. The magnitude of magnetic field we are interested in finding for the origin. So if you notice, if I name this conductor as C1, it will behave as a semi-infinite conductor. And due to this C1, if I apply the right hand thumb rule, let us imagine that I am holding it in this way. Then at O point, the fingers are curling in. So because of C1, the magnetic field direction at point O is going to be a cross. Then the circular, or you can 3/4 of the circle or 3/4 circles like this. Again, I apply right hand thumb rule. Let me name it C2. So because of C2, it is again a cross. Both will be added. And because of C3, as you can see, that is the axial conductor. Means I should say the O point is the axial point of this given conductor. Let's say it is C3. So this is going to be 0 on the axis of a straight current carrying conductor. The magnetic field is going to be 0. So if I write here BO net, then I will be writing it as B at point O due to C1 plus B at point O due to C2 plus B at point O due to C3. If I do it this way, we will realize that due to C3 it is going to be 0. Because of the first one, this can be written as, it's a semi-infinite configuration. So mu naught I naught or mu naught I by 4 pi this distance A. Mu naught I naught by 2 pi d is because of the infinite. So it is mu naught I by 4 pi because of the semi-infinite configuration. Okay. And because of this second term, you can say it is 3/4. So the correct formula should be, I apply the formula mu naught over 4 pi I into theta by r. Mu naught over 4 pi, or you can say a semicircle plus quarter circle, mu naught over 4 pi I into theta by r, or you can also say 3/4 of complete one. Theta is 3 pi by 2 Okay, pi by 2, pi by 2, pi by 2, 3 pi by 2 by r. Pi will be anyways getting cancelled, and this is also cross, है ना? And this is 3/4 of a circle. Fine. So 3 by 4 of mu naught I naught by 2r. You can also call it as 3 by 4 of mu naught I by 2r. Okay, same meaning. Now I think you can directly add them. Why to add them, sir? Because of both the direction is cross. So you can directly add them and you will get the answer. Alright. Easy question but good question. This is also one of the JEE PYQs which have a very high probability to get repeated in NEET. Alright. So make sure you revise all these questions which we are going through. So next is a moving coil galvanometer A has 200 turns and resistance 100 ohm. The number of turns and resistance is given to you. Another galvanometer B has 100 turns and resistance. New turns and new resistance is given. All the other quantities are same in both the cases. You have to comment about current sensitivity. So what is current sensitivity here? I will say, external torque will be equal to the magnetic torque for reading. So you say external torque, magnetic, or I should say magnetic torque and restoring torque for the reading should be same. So it is NIAB sin 90 because of radial field, and it is K into theta. So current sensitivity IS, which is deflection per unit current. So deflection per unit current will be equal to NAB by K, and it is independent of resistance. Okay. And so clearly, if you see, resistance doesn't matter here. You are changing this 100 ohm to 40 ohm. This change doesn't count. Okay, this change doesn't count. And what you are doing with the number of turns, 200 turns to 100 turns, here you are saying number of turns is halved. You see, current sensitivity is directly proportional to the number of turns. If number of turns is halved, so current sensitivity will also be halved. The current sensitivity of B is equal to half of the current sensitivity of A, or current sensitivity of A is double to that of B. Alright. Interestingly, so this is your answer. This is a very normal question. I'll also define another one. Vs is equal to Is by R. I hope you remember this, that according to Ohm's law, V is equal to IR. But in terms of sensitivity, Vs contain V in the denominator, Is contain I in the denominator. The correct formula in terms of sensitivity is Vs is equal to Is by R. So that will be equal to NAB by RKR. Just a tip, just a small tip. I am saying if you increase the number of turns, if n number of turns is increased, then definitely the resistance offered by that number of turns will also increase. So if you double the number of turns, the resistance in the denominator offered by double number of turns will also be doubled. So the effect of doubling the n will be compensated by effect of doubling the R. So you will say then current sensitivity definitely increases because it is directly proportional to n, but voltage sensitivity remains the same. Voltage sensitivity remains the same. What happens now? Whenever the examiner says that you are doubling the number of turns, which one will be doubled? So students see that Is is also directly proportional to n and Vs is also directly proportional to n. So if n is doubled, both will be doubled. That's not the appropriate answer here. If number of turns will be doubled, the resistance offered by that double length of the wire or number of turns will also be doubled, and hence numerator and denominator will be compensated. Vs might not change. Okay. Chaliye, going for the next one. A multi-range voltmeter. So now the question is of a multi-range. Multi-range voltmeter can be constructed by using a galvanometer circuit. So the moment you have heard about multi-range, I'll write the formula as Vmax is equal to Ig max, maximum deflection current, full deflection current, G galvanometer resistance plus R series in multi-range voltmeter. This and this they keep on changing for different ranges. These keep changing. Okay, these are the two things which are going to change. Now let us see. So the examiner is saying If we want to construct a voltmeter that can measure 2 volt, 20 volt and 200 volt using a galvanometer of resistance 10 ohm, galvanometer G value, resistance value is 10 ohm, produces a maximum deflection of 1 milliampere. So this is Ig max, this is G value. Okay, they are asking you the value of R1, R2 and R3, R1, R2 and R3. So let me write the three equations governing this problem. So the first one is, when I write the Vmax for the first one, when you connect these two, so 2 volt will be the reading and that will be equal to Ig max, 1 milliampere means 10 to the power minus 3, G plus R1, G plus R1 is 10 plus R1 from here. Next time you will be joining these two. I mean, one time you join this to this, one time you join this to this, and one time you are joining this one to this one, like this. Okay, so the next time your reading is 20 and that is 10 to the power minus 3, and this is 10 plus R1 plus R2, because R1 and R2, the moment you join this blue colored part, the R1 and R2 both will get in series with the galvanometer G, and then you have 200 and that will be equal to 10 to the power minus 3, and it is 10 plus R1 plus R2 plus R3. Let us try to solve all. So if I try to solve the first one will say, see, 10 to the power minus 3 on that side will become 10 to the power 3. So you will get 2000. 2000 is equal to 10 plus R1. 2000 is equal to 10 plus R1. This implies R1 will be equal to 1990 ohms, 1990 ohms. Okay, so 1990 is available in option A and option D. We can just compare the second one and we can get the final answer. See, second term. From here, 10 plus R1 was already 2000. Okay, keep it in mind. Here you see this 1000 on this side, 1 by 1000 on this side will become 1000 in the LHS. So you got 20,000 and that will be equal to 10 plus R1 plus R2. 10 plus R1 plus R2. But here 10 plus R1 value is already 2000. No need to keep R1 separately, then 10 separately. You can see this 20,000 will be equal to 2000 plus R2, and hence clearly you can see R2 will be equal to 18,000. Okay, ji, R2 will be equal to 18,000. So the correct option is option A. 1990, then 18,000, and then 1,80,000. How we can get 1,80,000? Just keep the value of 10 plus R1 plus R2, 10 plus R1 plus R2. This is basically from here, from this step, 10 plus R1 plus R2 is equal to 20,000. And this on this side will become, see, 2 lakhs, 1,000, 1 by 1000 on this side will be multiplied. 200 times the 1000 is 2 lakhs. 2 lakhs minus 20,000, you got 1,80,000. Is that clear? Have a look. Alright, so this was a problem based on multi-range voltmeter. People feel that the calculations are big. That's why if you notice, I have done each and every calculation in front of you. Next is a long straight wire of circular cross section of radius A carries a steady current I. The current is uniformly distributed across its cross section, which means it's not a hollow wire, it's a solid conducting wire which is conducting the current. The ratio of magnitudes of the magnetic field at a point A by 2 above the surface of the wire to that at point A by 2 below the surface of the wire. At a point A by 2 above the surface means R is equal to 3A by 2. R is equal to 3A by 2. Outer point, and A by 2 below its surface. A by 2 below its surface means inner point. A by 2 below its surface means inner point. Below the surface A by 2 means distance from the center or axis is again A by 2, and it is inner point. So outer point के लिए the formula for inner point is B in is equal to mu naught I small r by 2 pi capital R square, and B out formula is mu naught I by 2 pi r. These are the NCERT formula for inside point and outside point for a solid conducting wire. Okay. Now what they are asking is the ratio of the two. Above the surface means the red colored to pink colored ratio they are asking. So I'll do it here. See, B at R is equal to 3A by 2 by B at R is equal to A by 2. So R is equal to 3A by 2, you have to fit in the outside formula, that is mu naught I by 2 pi, and that's 3A by 2. Out formula, and in formula, because R is equal to A by 2, so you'll be having mu naught I into small r. Small r is the distance from the axis or the center, that is A by 2, by you can say 2 pi capital R square, that capital R square is A square. This time the radius is A. See, the radius is A. In the first line they are telling that the radius is A. Okay. So now if I try to simplify that, I can see mu naught I by 2 pi, mu naught I by 2 pi will be cancelled. So what you got here is 1 by 3A by 2. Okay. 1 by 3A by 2, mu naught I by 2 pi, mu naught I by 2 pi is cancelled. And here it is, I think 1 by 2, A by 2 in fact, 1A will be cancelled, 1 by 2A. 1 by 2A. Okay, you got this. So what else? I will say AA will be again cancelled here. If you want to simplify this, what you can write? 1 by 3A by 2, and it is 2A by 1. Okay, so that will be equal to 2 by 3A into 2A by 1. So what is the answer finally? I think 4 by 3. AA got cancelled. I am getting the answer as 4 by 3. You can compare. Is that clear? So basic calculation here, the calculation I think you can still check, but the main thing you need to learn here is that the points were different. One is inside point, one is outside point. So the values to be substituted in the formula are different, but the formula to be used are also different, because you can't apply the same formula for inner and outer point. I hope that's clear. Next is assertion: a proton and an alpha particle having the same kinetic energy are moving in circular paths in a uniform magnetic field. The radii of the circular paths will be equal. So first of all, I have to see that what will be the formula governing this. So for same kinetic energy, basically we write R is equal to mv by bq. If you want to write it in terms of kinetic energy, I can write it as under root of 2m kinetic energy by bq. So clearly you can see that R is directly proportional to root m by q, because 2 kinetic energy and B will be same. So R is directly proportional to root m by q. So suppose I try to write the value of root m by q for proton as well as what is the other particle? Alpha particle. Okay. So for proton, you will be having the mass as 1 unit and the charge is also as 1 unit. And for the alpha particle, you will have mass as 4 unit and the charge as 2 unit. So this is also 1. This is also 1. So I think by solving it and taking the proportionality of root m by q, we are getting the assertion to be corrected. Okay, that the radii of the circular paths will be equal. So assertion is true. Okay, true. Reason: any two charged particles having equal kinetic energy and entering a region of magnetic field in a perpendicular direction describing circular path of equal radii. Any two charged particles equal radii, not necessary. Why, sir? Because why the assertion was true, we have checked it mathematically. So every time for every charged particle doing the same process, this mathematics will come out to be same. It's not necessary, no? It's not necessary. Okay. So because that's not suitable for all the particles, I will say the reason is false. So the correct thing is assertion is correct, reason is false. Assertion is correct and reason is incorrect. Option D is true. All right. Let's move on to the next one. A long straight wire of a cross section, circular cross section, carries a steady current I, and the current I is uniformly distributed across its cross section. Which of the following plots represents the variation of magnetic field? So I didn't take the option because I'll draw this for you. I will say that the B inside, that is when till the time r is less than equal to capital R, the formula which we have used previously in the numerical is mu naught I small r by 2 pi capital R square. That is, you will say B inside is directly proportional to R, and B outside, that will be, that is, R is greater than equal to R. So that will be equal to mu naught I by 2 pi small r, that is B out, you will say is inversely proportional to R. So inside point directly proportional to R, outside point inversely proportional to R. So B versus R 0, and this is capital R. So you will say inside point it is directly proportional to R. The B max is mu naught I by 2 pi capital R. This is the B maximum value possible for this straight wire, and after this it is inversely proportional. So see, B out is inversely proportional, rectangular hyperbolic part. B in is directly proportional, straight line passing from the origin. Alright, that's the appropriate graph for this. So what if for a hollow cylindrical wire, if they talk about, for a hollow cylindrical wire, B inside is going to be 0 and B outside is same as that of this one, that is mu naught I by 2 pi R. So if you are trying to draw the graph, that is B versus R for a hollow one, it is going to be like this. For a hollow, inside it is 0, B inside 0, outside it will show this, again the rectangular hyperbolic part. Is it clear? Alright, so be specific what the examiner is talking about. Here they talked about the solid one in which the current passes through the entire cross section, and here we have taken about, we have talked about the hollow also. So your correct option should be this one. Okay, let's move ahead. Now, this is also another question of JEE which looks very complicated, very mathematical, but it is just a very, a nice conceptual problem which can be done in one step or two step, or one step in fact I would say. Let us read that question carefully. Although if this type of question comes in the NEET exam, you must do it in the second scan. This is not a first scan problem because this might be a new problem for you, and also the size of the question contributes a lot. So n equally spaced charges of value q are placed on a circle of radius r. So let us consider this circle of radius r, and in this on this circle of radius r, n equal charges are kept. N equal charges are kept like this. That is also shown in the diagram, but I am re-explaining it to you. The circle rotates about its axis with an angular velocity omega. So this circle is supposed to be rotated about this axis with an angular speed omega, like this. A bigger Amperian loop B encloses the whole circle. So if it is this loop, Amperian loop B, so can I say through this loop, whatever number of charges per second are going from right to left, the same number of charges are coming from left to right, because it is enclosing the entire loop. So charges going like this and charges coming like this are going to be same. So here current enclosed will be 0. Here current enclosed in loop B is going to be 0. Okay. Now a bigger Amperian loop B encloses the whole circle, and as a smaller Amperian loop A encloses the small segment. A smaller Amperian loop A, suppose this is the Amperian loop A. So here the I enclosed current in A is non-zero. In fact, the number of charges passing through this loop per unit area of the cross-sectional area of this loop will contribute to the current. So that can be written as, but that can be written as how much? That can be written as Q by T. So n number of charges and Q by T. Okay. So this T can be written as 2 pi by omega. So that can be written as n omega q by 2 pi. N omega q by 2 pi, I think. Okay. N omega q by 2 pi. So what they are telling is the difference between enclosed currents IA minus IB. Obviously here, so clearly what you can say, IA minus IB, where IB is 0. IB is 0 now, that's what you have commented. So that will be equal to n omega q by 2 pi. Very simple. So the correct option is n omega q by 2 pi, option 3. It's a very simple problem. We just counted the current, or basic formula of current I have used. Total Q by total time. Time is 2 pi by omega. You would have seen this use of formula many times. So the question looked very big, but you just needed to visualize that what is the net current threading through the loop. So in the loop B, threading current means entering and exiting, right? You have to encounter both, but they are equal and opposite, and hence the threading current is 0. That is the basic way of using the Ampere's circuital law. Next is a square loop ABCD carrying a current I is placed near and coplanar along a long straight conductor XY carrying a current I. They are asking the net force on the loop. So first of all, I'll try to draw the direction of magnetic field due to this source current. So due to the source current, the magnetic field is in the inner region cross, and that will keep on reducing, right? That will keep on reducing like this. Because greater is the distance of separation from the straight conductor, the loop, the magnetic field will keep on reducing. Is that clear? Let me see whether it is visible to you. Yeah, it's visible. Now, we have to see the direction of current experienced by all. So in this, because of this clockwise current, the current is in the like direction, and like current carrying conductors attract each other. So it will be a very strong attraction. For the same reason here, there will be a small repulsion because the magnetic field has become weaker. If the magnetic field has become weaker, there will be a weaker force, which is the repulsive force here. If you see the upper one, the current is going like this, magnetic field is inside, current is going forward, magnetic field is inside. So by Palm rule or Fleming's left hand rule, you can see the magnetic force will keep on reducing. Here also the magnetic force, because of the rules, they will keep on decreasing. Although these forces are non-uniform, keep on decreasing, but they are symmetrical, symmetrically opposite. So this and this will not experience any force. Only this arm will experience a strong attraction, and this arm will experience a weak repulsion. So I will say the net force on the loop, F net, will be equal to F on the left wire, that is strong attraction, minus F on the right wire, right arm, which is weak repulsion. Alright, and the formula for magnetic force is BVL. So BVL so the first term I am writing here, B, magnetic field in its region because of the straight wire, that is mu naught I by 2 pi, the separation between them is L by 2. BVL is the formula of induced EMF, okay. IBL is the formula for magnetic force, IBL sin theta. So BIL, if I am writing, this is the B, current is flowing I, small I, and length of this conductor is capital L. And similarly, if you try to write for this BIL, magnetic field in its region is mu naught I by, the total separation between the straight conductor and the further arm, the right arm, is basically L by 2 plus L. L by 2 plus L is 3L by 2. So 2 pi, and here it is 3L by 2, and it is small I into the length of this conductor is also L. So obviously you are going to do the minus here. So what you can take common outside is, see, mu naught, this L cancelled, 2 cancelled. So what you can take common is mu naught capital I small I, L cancelled, 2 also cancelled, this is pi, and here it is 1 minus 1 by 3. See, 1 minus 1 by 3 is 2 by 3. I think the final answer is 2 mu naught II by 3 pi. 2 mu naught I small I by 3 pi. I think first option is coming. I hope it is clear. I explained you each and every part involved in this particular, in this loop. Alright. Next is a particle having a mass of, that is a given mass, contains a given charge. The particle is given an horizontal initial velocity of something and the presence of electric and magnetic field. to keep the particle moving in a horizontal direction, to keep the particle moving in horizontal direction, it is necessary that, see, if you want the particle to be moving in horizontal direction, you don't want to change its direction of velocity, which means both B and E should be along the direction of velocity, can be there. Both B and E are, so B should be perpendicular. Let us judge one by one. B should be perpendicular to the direction of velocity and E should be along the direction of velocity. E should be along the direction of velocity. This won't change V cap. But B should be perpendicular to the direction of velocity, will change B cap, will try to make it move, will try to move in a circular path, will try to move in circle, or later on the different types of paths will be there, or curved. I'm just writing it, move in a curved path. Let's not call it circle because the electric field will be having the capability to change the velocity and hence the radius, change the speed. So this is not possible here. It will definitely try to make it move in a circle. What next? Both B and D should be along the direction of velocity. Acceptable. Because along the direction of velocity, if magnetic field is there, there is no magnetic force. Electric field is there, there is an electric force, electrostatic force, but that will be parallel to the direction of field, which means will not change the direction of V, can be changing the magnitude. Both B and E are mutually perpendicular and perpendicular to the direction of velocity. This is also acceptable. How this is acceptable, sir? Like velocity filter. Acceptable like velocity selector or velocity filter. When magnetic field and magnetic force both are there, but the net Lorentz force is 0. F Lorentz is 0, which means that is, you can say electrostatic force is opposite to, like equal and opposite to magnet force. So this is acceptable. B and C both are acceptable. Let's talk about D. B should be along the direction of velocity and E should be perpendicular to the direction of velocity. If E should be perpendicular to the direction of velocity, it will surely change V cap. It will surely change the direction of velocity V cap or V vector. Okay. Which simply means that you don't want any deviation. You want the particle to keep moving in the horizontal direction. Hence, the appropriate set of options should be B and C. C already highlighted. I hope the reasoning of all these parts are clear to you. All right. Next is magnetism and matter, right? Diamagnetic, paramagnetic, ferromagnetic substances, bar magnet and related properties. Terrestrial magnetism, declination, inclination and horizontal component has been deleted. So magnetic behavior of substances as well as bar magnet and properties we have to do. Terrestrial magnetism, geomagnetism you don't have to do. Okay. So the question is, like that is deleted from NEET. Question is, which of the following statements are true about the magnetic susceptibility of paramagnetic substance? You know, a brief introduction of the magnetic susceptibility again. First of all, mu r value will be equal to mu m by mu naught. Okay. And magnetic susceptibility will be equal to mu r minus 1. Alright. This you have to comment about diamagnetic, paramagnetic and ferromagnetic. So, in case of diamagnetic substance, mu m is less than mu naught. This implies mu r is less than 1. Paramagnetic substance, mu m is greater than mu naught. Mu r value is greater than 1. Ferromagnetic substance, mu m is greater than mu naught. And mu r is greater than 1. If we talk about this magnetic susceptibility, less than 1 minus 1 is negative. Less than 1, greater than 1 minus 1 is slightly positive. And if we talk about ferromagnetic, greater than 1 minus 1, it is highly positive. Okay. What they are commenting about is the value of magnetic susceptibility for a paramagnetic substance is slightly positive and decreases with temperature. How it decreases with temperature? It decreases with temperature by Curie's law, that magnetic susceptibility is Curie constant by T. Curie's constant by T. Okay. That is the story. Now let us read the options. they are saying are true, is or are true. So magnetic susceptibility is negative at all temperature. Magnetic susceptibility will be negative at all temperature, false, because that will be true for diamagnetic. Value of magnetic susceptibility is inversely proportional to the absolute temperature of the sample. Yes, that is called the Curie's law. Curie's law in magnetism. Magnetic susceptibility is 0 at all temperature, false. Susceptibility does not depend on the temperature of the sample, false. That may be valid for a diamagnetic substance. Okay, I hope that's clear to you. Next is, there is a this is a JEE problem, and this is a controversial problem. That's why I have inserted the fifth option there. I'll explain it to you. What they are saying, that there is a bar magnet that has a total length 2L is equal to 20 units, and the field is to be considered at point P at a distance of D is equal to 10 units from the center of the magnet. If the relative uncertainty of the length measurement is 1%, then uncertainty of the magnetic field at point P is, uncertainty at point P is. For this problem, I would suggest you, I'm not getting into too much of the explanation of that. For this problem, I'm suggesting you to remember these two, and hence this will be the one. Okay, as per approximate NCERT results. So this is just a controversial one. We can also get on to one of the answers that way, but right now we are not getting too much, right? For this problem, I would suggest you to, correlate the options. You apply the NCERT formula. I am not telling you to memorize it. I am telling you, on the basis of the NCERT formula, try your own, and if you are getting any of these two, don't be, don't panic. Both can be acceptable. Okay, because if the problem is repeated, we never know that which option will be coming for us. So we need to be prepared for both the options. Next is a very common model. A magnetized wire of magnetic moment m and length is bent. Its geometry is changed. So whenever you change the geometry, the pole strength never changes, but the separation between the poles may change, and as a result, the magnetic moment of the magnetized needle or wire will also change. So the new magnetic moment is, let us see what is happening. So you have a magnetized wire, and this is north pole, this is south pole, plus m minus m be the pole strength. Okay, and there is some distance between them. Let it be L. So initial magnetic moment capital M is small m into L. Now what you are doing is, you are changing it into a semicircle. If you are changing it into a semicircle like this is north pole having the plus m pole strength, this is south pole having the minus m pole strength. The separation will become 2r. Now from here to here, do you agree that L is equal to pi r? L is equal to pi r, not 2 pi r, because you have not changed it into complete circumference, but a semicircle. Or you can say r is equal to L by pi. So the moment you will write this 2r, m final will be equal to, pole strength will remain the same, but the separation has been changed to 2r. So pole strength into 2, and this r value, let's keep it small r here. This r value can be written as L by pi. So what you got is 2 by pi separately, m into L. This m into L was nothing but the old magnetic moment. So it is m initial into 2 by pi. And that's already your highlighted answer, m initial into 2 by pi. Or if they don't write it that way, okay, did we miss something? Did we substitute the pi there? Oh, actually we were expecting this answer, but the options are not matching directly. 2m by pi. So we can also substitute this pi, rather, very rare substitution here. Pi is equal to L by r. The moment you substitute pi is equal to L by r, m final will be equal to m initial. 2, pi in the denominator is L by r, so that will become 2r by L. 2r by L. Oh, generally it never happens here, because in these type of problems we actually get that answer, but I would say the same, that examiner knows what majority of students will do. So they might, rush to answer anything between A, C and D, but what rare substitution they have done is they have substituted pi Generally, they substitute one physical quantity in terms of other physical quantity. We never substitute the numerical constants, 2, 3, pi, like that. But here in this particular model, they have substituted the numerical constant pi. Okay, you must take a screenshot of this. Alright, let's move ahead. Next is a coil. That's a NEET PYQ already, but one of the best problems which have come. And it's easy. Whenever I say this is one of the best problem, that I really don't mean that I am pointing out towards the difficulty of the problem. No, but it is interesting problem, sometimes involving the common mistake, sometimes involving a nice visualization. So this is one of the good problems. A coil in the shape of an equilateral triangle of side L is suspended between the pole pieces of a permanent magnet. So it's a magnetic field available there such that B is in the plane of the coil. So if you have B in the plane of the coil, so this is the scenario, this is an equilateral triangle and the magnetic field is in the plane of the coil. So the area vector will be like this, n cap or a cap or magnetic moment cap. So the angle between these two vectors, B vector and A vector, is going to be 90 degree. Torque will be maximum. It will not be in equilibrium. If due to a current in the triangle, a torque tau acts on it, the side length of the triangle is. So can I say here, if they are talking about the torque, then I will say tau will be equal to NIAB sine theta. This implies tau, the number of turn is 1 only, current is I. Area of equilateral triangle is root 3 by 4 side square and B is given and it is sine 90 degrees. From here they are asking you the value of L. So I will say this 4 will be multiplied there, 4 into tau by it is root 3 IB and that is equal to L square. That means L will be equal to twice of tau by root 3 IB whole to the power 1 by 2. Only this 4 will come out of the root or half power as 2. So 2 tau by root 3 IB whole to the power 1 by 2. I think option B is correct. You can check. Alright. Let's go for the next. Now, there is a long bar magnet of time period T is cut into 4 equal parts by cutting it perpendicular to length and breadth both. So it's a long bar magnet, you cut perpendicular, you cut parallel to the length, both the cases. The time period of each part is. So if you have a bar magnet, a big bar magnet like this, and now you cut it by 2 axes, this will reduce the magnetic moment into half. This will reduce the pole strength into half. M final will be equal to small m initial by 2. And doing this will reduce the length into half. So L final will be equal to L initial by 2. And now if you are talking about any one part, so you will say your magnetic moment here will be equal to M final into L final, magnetic moment final. So that will be equal to M final is M initial by 2 and L final is L initial by 2. So the magnetic moment is M initial by 4. The magnetic moment has become 1 by 4. What next? Moment of inertia, because they are talking about the time period of each part, time period of oscillation of each part. Moment of inertia finally will be equal to mass final into length final cos square by 12, ml square by 12, because each magnet will rotate like this. If each magnet is rotating like this, you will say about the center of mass axis. So mass has become 1 by 4. Mass has become 1 by 4. So it is m initial by 4 or m naught initial. Let me write it like this. Mass initial by 4. And length has become 1 by 2. Length has become half. So length initial by 2, but you have to write it square by 12. Okay. So what you got here is 1 by 4 and 1 by 4. So this is I initial by 16. Mass has become 1 by 4, the length has become 1 by 2, but its square will come. So it is I by 16. Now from these two, if you have to comment, time period is equal to 2 pi under root I by MB external. I by mb external. What you are doing with the moment of inertia? You are doing with the moment of inertia 1 by 16 times. 1 by 16. And what you are doing with the magnetic moment? You are doing the magnetic moment 1 by 4 times. So see, the numerator 1 by 16 will be cancelled by denominators 1 by 4 at 1 by 4 times. 4 will cancel 16 at 4 times. So 1 by 4 will come outside the square root as 1 by 2. This implies T final will be equal to T initial by 2. T final will be equal to T initial by 2, and hence the final answer is B. Check for each step once. See what is happening with magnetic moment. There will be a change in pole strength, there will be a change in magnetic length, hence there will be a change in magnetic moment. There will be a change in mass, there will be a change in length, hence there will be a change in moment of inertia. If you miss out any of the change, then the probable options which will be wrongly coming are also hopefully available in the, available in the options. So examiner knows what common mistakes students are generally doing. Okay, make sure you see that. You can also take the screenshot. Alright, going for the next. A cycle wheel of radius is given to you, rotated with a constant angular velocity, which is perpendicular to the plane of the wheel. So there is a cycle wheel. Then the EMF generated between the center and the rim. The EMF induced between center and rim. Center and rim. The formula is equal to B omega L square by 2 or B omega R square by 2, irrespective of number of spokes in the cycle wheel. Number of spokes doesn't matter. Irrespective of number of spokes. Here number of spokes doesn't matter. Calculation I am leaving it for you. Also a tip from my side, that if they are asking the EMF induced across diameter, the EMF induced across a diameter, that is also 0, and EMF induced across, so EMF induced between the center and rim or across radius, the formula is given by B omega R square by 2. But if they ask you the EMF induced across the diameter or EMF induced across the chord, so understand that center and rim will be a different potential. But diameter means both the endpoints are over the rim. Chord also means both the endpoints are over the rim. So between two rim points or between two peripheral points, there will be no potential difference. So what I am writing here is all peripheral points are equipotential. Means the entire rim is at equal potential, maybe lesser than that, lesser than the center, maybe higher than the center. That depends on the direction of magnetic field and the sense of rotation of the wheel. But in both the cases, in any of the case, peripheral points must be at the same potential. So there is no potential difference across the diameter as well as the chord, but there can be a potential difference depending upon the situation, angle and everything across the radius. The formula is that. I hope you will do the calculation and match up the answer. Remember this step. Examiner knows that students memorize this, and maybe they will keep everything same in this question. They will just say the EMF generated between its center and the rim. Instead of saying this, they may say that EMF generated across the diameter. So they will give all the data, but remember, all the data is a useless data. That is just to confuse you. And see, one of the option is 0 also. Diameter and chord ke across, it is 0. But the answer of this problem will be given by that. Let's move on to the next one. So that was rotational motional EMF. This is a translational motional EMF. Rotational motional EMF induced EMF formula is B omega L square by 2. Translational motional EMF induced EMF formula is BVL perpendicular, B perpendicular, V perpendicular, L perpendicular. So uniform magnetic field of induction, this exists in the region to the left of the line PQ. The loop ABCD is being pulled out from the magnetic region with the velocity of this. If length AD is equal to BC 2 meter and AB is equal to CD 1 meter, AB is equal to CD, AD and BC, okay, I'll mention it. AD and BC, this is 2 meter and this length is 1 meter here. The current flowing through 10 ohm resistor is, So I will say, let's do it step by step. Here I can write the induced EMF. Here I will be writing the induced EMF. Formula will be B perpendicular, V perpendicular, L perpendicular. Okay. And if I imagine a positive charge here, because you are moving the rod like this, if I imagine a positive charge here, the positive charge is moving ahead, forward. The magnetic field is inside. The positive charge is moving forward. The magnetic field is inside. So where is the palm facing? Up. What they said, a uniform magnetic field exists in the region to the left of the line PQ, and the loop CD is the current flowing, the loop CD is being pulled out. Okay, you can analyze it this way also, that here if you are pulling it out, the cross flux decreases with time. If the cross flux decreases with time, this implies we need to support it. Support it. If we need to support it, if we want to support the clockwise current, because clockwise current, cross flux was decreasing. If we want to support the cross flux, the fingers must be clockwise. So you will say clockwise induced current. Clockwise induced current. Okay, this much you can conclude. Now, induced EMF is B perpendicular, V perpendicular, L perpendicular. The perpendicular magnetic field which is inside, that is 1.5 Tesla. Given in the question. The V value is 2 meter per second, and you understand the magnetic field is inside, the velocity is forward, so the length is to be perpendicular. This must be the length, not this 2 meter. 2 meter is parallel to 2 meter per second. You don't have to keep the parallel parameter, you have to keep the perpendicular one. So that is 1. So it is 3 volts here. So I induced will be equal to E induced by R. So that is equal to 3 volt, and the R is given to you of the network as 10 ohms. Hence the answer is 0.3 amperes. And as you said, clockwise induced current, so the clockwise induced current is going to be A to B. Clockwise induced current A to B, that's your answer. Think second option. Alright. So rotational motional EMF B omega R square by 2, not across the dia, not across the cord. Translational motional EMF is B, V, L, all should be perpendicular to each other. Lenz law ke according to the Lenz law, if the flux is reducing with time, we want to support it. If the flux is increasing with time, we want to oppose it. And to maintain this current, the inertia of electricity, to maintain the strength of current, this property is also called as inductance. Alright. Let's move on to the next one. A big circular coil of 100 turns and average radius circular coil number of turn is given. Number of what is given to you? Number of turns is given to you. Radius is given to you. Omega is given to you, 2 radian per second. Vertical component of Earth's magnetic field is given to you. The electrical resistance of the coil is given to you, and they are asking you the maximum induced EMF, maximum induced current, they are asking you the maximum induced current. So can I say I induced maximum, rotation of coil produces the EMF, that is the principle of generator. Rotation of coil induces an EMF, that is principle of generator. Okay. So here the I induced maximum will be E induced maximum by R. E induced maximum is given by NBA omega by R. So NBA omega by R, this small r, let me write it as radius. This is radius here, and this is resistance here. Okay, G. So what you can do is, that can also be written as NBV, A can be written as pi small r square into omega by R. Leaving the calculation on you, all these things are given in the problem. First thing is always the concept. What we have identified the concept, rotational motional EMF is done, translational motional EMF is done, Lenz law discussion is done. Now this is the principle of generator, rotating the coil resulting into an induced EMF, hence induced current. Next, a 100 ohm resistance and a capacitor of 100 ohm reactance are connected in series across a 220 volt source. reactance and resistance, both the things are given, and definitely reactance will be entertained if you are talking about AC. And in case of AC circuits, how much percentage of the capacitor has been charged, it doesn't matter. So when the capacitor is 50% charged, this thing doesn't matter in AC circuits. In DC circuits it matters, but in DC circuits it can't offer a reactance. Okay, reactance is offered means AC chapter question it is, right? And they are asking you the peak value of the displacement current. So can I say I naught of displacement current according to the continuity of current, that is equal to I naught of conduction current? Yes or no? Conduction current and displacement current are always equal continuity of current. Okay, in that case I will say that will be equal to E naught by Z. E naught by Z. E naught can be written as √2 times ERMS, because the rated values are always RMS value. Z can be written as under root of R square plus XC square, but both are given to be same in the question, and that same data is 100 ohms. So what you got here is √2 times ERMS is 220 and this is 100 √2. √2 got cancelled. Answer is 2.2 ohms, 2.2 amperes. Is that clear? Every small aspect of the problem we have focused on. We have said that in case if it is offering reactance, which means it is AC. In case of AC, the percentage charge of the capacitor doesn't matter. Displacement current they are asking, but according to the continuity of current, displacement current and conduction current are always equal. Okay, that's it. Next one. A capacitor and an inductor coil are connected in separate AC circuits. Very nice problem, very conceptual. Very nice. Separate with a bulb. So let me take it as a capacitor and an inductance coil are connected with a bulb. This is connected with a bulb with an AC, and the other one is inductor coil connected with a bulb with an AC supply. Okay, you have to choose. The bulb glows more brightly. The bulb glows more brightly. I'll talk about it one by one. I'll talk about all the 4 options. Okay, see, separation between the plates of the capacitor is increased. Separation between the plates of the capacitor is increased, which means you are talking about this circuit. So statement 1, if separation D between the plates of capacitance will increase, that means capacitance, which is epsilon naught A by D, will decrease. If capacitance inversely proportional to D decreases, XC, which is 1 by omega C, is increases. If XC, position offered by capacitor will increase, so drop across the capacitor will increase. Drop across the capacitor will increase, so drop across the bulb will decrease. If there is less drop across the bulb, it will glow less brighter. Less brighter. Okay. So, but we are interested in more brightly. So, first option is gone. Second option, dielectric is introduced between the gap of the plates. Number 2, if dielectric is inserted between the gap of the plates, epsilon R increases. This implies capacitance increases. Capacitance increases, so XC decreases. V across the capacitor will decrease. So, V across the bulb will increase, and hence it will glow more bright. It will glow more brighter, and hence this is your answer. But I will also talk about the remaining 2 options, because we will take it as an opportunity to revise the other effects produced. These 2 options were only stated regarding the capacitor circuit. The inductor circuit is yet to be talked about. Now, let us see the next one. Next one, they are talking about an iron rod is introduced in the inductance coil. An iron rod is introduced in the inductance coil. You see here, so mu R value is increased. How do you know, sir? Because iron is a ferromagnetic substance. Okay, iron is a ferromagnetic substance. Mu R value is increased. This implies XL value is increased. If X, because that is directly proportional to L, V across the L will increase. V across the bulb will decrease. If V across the bulb will decrease, again you will say it is going to glow less brighter. Less brighter. This is your more bright answer. This you have already selected, but still we are talking about the remaining. And let us talk about option 4 now. Option 4 says the number of turns in the inductance coil is increased. If the number of turns is increased, again you will say the self-inductance value. Okay, I missed this step also here. The self-inductance value will increase. Okay, so here also it is the self-inductance value, exactly same here, same story. Okay, Ji, exactly same behavior will happen. Both the parameters are contributing towards the increment of the inductance value. I hope that's clear. Just have a look. I'll have some water. Then we'll continue in a minute. Yes, all right. Audible now? Right. Let's move on to the next one here. In a transformer, this is a problem which I have taken because generally people talk about the transformer like E2 by E1, N2 by N1, transformation ratio, step up, step down, everything. But they generally don't focus on the types of losses in the transformer and methods of their prevention. That is also an important NCERT thing. So in a transformer, the source of energy loss and the precaution to minimize them is given to you. You have to match them up. So eddy current, hysteresis and eddy current loss, how they are minimized primarily. Eddy current losses, you have always heard about transformer cores generally laminated soft iron core. Okay, so why it is laminated? Generally it is laminated to minimize eddy current loss. What do you mean by lamination, sir? Does lamination means outer covering like we laminate the books, mobile phones, this, that? No. Here the lamination means that it is made in the form of thin sheets. Each layer is electrically insulated with the next one. So any eddy current which is produced, that will be restricted in its own layer, hence minimizing the heat loss due to eddy current. And soft iron. Why soft iron? To minimize the hysteresis loss. For soft iron, the area under the hysteresis curve is very less. So in the cycle of magnetization or demagnetization, commonly called as hysteresis, the energy loss is relatively less. So to minimize hysteresis loss. Okay. To minimize hysteresis loss. So here I will say how to match it up. See, primary and secondary coils are thick wire and this thin sheets of laminated core. So eddy current is minimized by thin sheets of laminated core. Hysteresis is minimized because of the soft iron. Resistance of winding, if you take thick wire in high current windings, wire will be thick and thin, that will affect the area of cross section and hence the resistance. So I think we can C and D, C is matching to P and D is matching to R, C is matching to P and D is matching to R. Anyways, this is one of that. A is matching to S, flux linkage is matching to this. Okay, and resistance of windings will be related to the thickness of the winding because the resistance affects on the area, depends on the area of cross section. So you will say these two are related to each other. Alright, that's easy to judge. Remember especially these two. Laminated means making into thin sheets electrically insulated with each other, minimizes the eddy current losses. Cycle of magnetization and demagnetization is called hysteresis. Area under the curve is a measure of hysteresis loss. Soft iron ke liye, for the soft iron the area will be relatively less. Next. Yeah, another interesting and important problem. An inductor, a resistor and two identical bulbs B1 and B2 are connected to a battery through a switch S as shown in the figure. The resistance of the coil having inductance L is also R. So there, this is not alone L, this is also R is also there. Okay. So which of the following statement gives the correct description? See, the earlier problems were of AC, alternating current. Here it's a DC source. Here it's a DC source. So the behavior of inductor is not to steadily offer the inductive reactance. Rather, the behavior of inductor will be time varying. It will keep on changing with time. Towards AC, it offers a steady opposition. Capacitor offers a steady opposition called capacitive reactance. Inductor keeps on offering a steady opposition called inductive reactance. But towards DC, time varying behavior of capacitor and inductor is observed. Capacitor conducts fully at the start and after getting fully charged, it behaves as open circuit. Inductor behaves as open circuit at the start due to very high value of self-induced EMF, and with time gradually, slowly it allows the changes. So here, the moment you will close the switch, inductor will not allow the current to flow suddenly. Inductor will not allow the current to flow suddenly. So initially, which one will glow? The initially B2 bulb will glow. But finally, when inductor behaves as open circuit, inductor behaves as normal wire according to the question, offering the same resistance R, this implies both arms are identical. If both arms are identical, so both will glow equally, which means the bulb B2 will light earlier than B1 and finally both the bulbs shine equally. Bulb B2 lights earlier, but finally because of the identical resistance offered by resistance and the inductive wire, both will shine equally. But suppose this is so this is the answer, this is the question. But suppose in the NEET exam, they say that we are talking about an ideal inductor. So if they are talking about an ideal inductor, so initially inductor will not allow the sudden current to flow. But finally, gradually or slow changes are allowed. So inductor will be satisfied, will behave as a short. So in the upper wire, only bulb B1 will be there. And in the lower wire, along with bulb B2, there will be a resistor there, which will take some potential or take some power along with it. So I will say in case of ideal, initially B2 will glow, but finally B1 will glow brighter because there is no additional resistance there in case of ideal inductor. So B2 lights up earlier and finally B1 shines brighter than B2 if inductor is ideal. If inductor is ideal means no resistance offered, that is internal resistance offered will be 0. In this question, its resistance was given to you. But if internal resistance or the resistance offered by the inductor is 0, then instead of option A, we would have selected option C. Remember both of them. Alright, next. In AC circuit, the power factor is, what is the power factor? Power factor is equal to cos phi is equal to R by Z. Okay, R by Z. In purely resistive or at resonance in series LCR. Because in series LCR it's not pure resistive, but at resonance it behaves as a purely resistive. So or at resonance in series LCR, what we say the Z value is equal to R, and hence this implies cos phi will be equal to R by Z, which is equal to R, or you can say power factor is equal to 1 unity. Power factor is equal to 1 unity in case of pure resistor or in case of resonance in series LCR circuit. In purely resistive, in purely inductive or purely capacitive. In purely inductive or purely capacitive, the resistance value is 0. This implies cos phi or power factor is also 0 by something, so that is going to be 0. So purely inductive and purely capacitive case mein the power factor is going to be 0. Okay, so the correct option you can already see. It is unity in case of ideal resistance and it is 0 in case of ideal capacitor or ideal inductor. So both the options are true. Alright, let's move on to the next one. In the given branch AB of a circuit, a current I is flowing where T is in time, the potential difference between points A and B they are asking. They are asking the potential difference between points A and B. Okay. I think the options are clear to you. I'm minimizing the size so that I can draw the circuit on my own. Before that, I would like to analyze the values a bit. This I is equal to 10t plus 5. So from this function, what you can say? Current increases with time. Current increases with time. We have concluded. See, because it shows a linear variation with time. What is the rate of change of current? Di by dt. The rate of change of current is 10 into 1 plus 0. So that is equal to 10 amperes per second. Okay. And what is the value of current at t equals to 0? Because they are interested in the potential difference finding at t equals to 0. So current at t equals to 0 will be equal to 10 into 0 plus 5. So that is equal to 5 amperes. If this current is increasing with time, this implies inductor will try to oppose it. If current decreases, inductor tries to support it. But if the current will increasing with time, inductor will try to oppose it. Now let's draw the circuit once again. This is point B and this is 10 volt. Okay. The inductor is 1 Henry, and this is the current I and this direction, and the resistance R is equal to 3 ohms. Resistance R is equal to 3 ohms and this is point A. And we are interested in VA minus VB. So if we are interested in VA minus VB, let us imagine a battery here. VA minus VB is, I do it this way. VA minus VB is VAB, higher, lower. So that is VA minus VB. If they would have asked you VB minus VA, I will consider this VB as the bigger polarity. But since they are asking VA minus VB, VA is the higher polarity. Now, what is the value of this current? You have calculated already there. This current is 5 ampere. And this current is basically increasing with time. So the inductor will try to oppose it. So inductor's polarity of induced EMF will be this, so that it can oppose the current. It can oppose the current by sending the current like this. This E induced magnitude is equal to mod of L di by dt. Space is a bit less, directly writing the magnitude. L di by dt, L is 1 and di by dt is 10. L is 1 and di by dt is 10, so it is 10 volts. 10 volts. Now I'll apply KVL. I'll apply KVL like this in this loop. So how to apply the KVL in this loop? I'll write the equal to one side EMFs, one side IRs. What is the convention of writing the EMFs? If you hit the negative terminal of the battery, you will write the EMF as positive. Positive terminal of battery, you will write the EMF as negative. So when you are hitting this negative, you are writing it as, plus VAB. Then you are going here, and you are hitting the positive terminal of 10. So it is minus 10. And then you are hitting this negative terminal of the 10. So plus 10. That is equal to IR. Current and you are in the same direction. So that is 5 into 3. So plus 10 minus 10 got cancelled. This implies plus 10 minus 10 got cancelled. I got VAB is equal to 15 volts. You please check the calculation, and as of now I am sticking with the 15 volt opinion, plus 15 volts. Okay, you can just check all the plus minus and logic over there. So what did we learn? Whenever they ask the potential difference between any 2 points, I consider an imaginary battery and I take the support of the universal rules. Those are KCL and KVL. Apart from that, we have considered the behavior of the inductor. If the current increases with time, inductor will try to reduce it. If the current will decrease with time, inductor will try to increase it. Right? Next. A small square loop of wire A of side length L is placed inside a large square loop, and they are asking the mutual induction can be derived. Way 1, The mutual induction value can be derived. It's a common question. But they are not asking the exact formula. They are asking the proportionality, way to proportionality. So I will say mutual induction is directly proportional to the area of for which we write the flux, for which flux is written. Flux is written by the dimension of the length which creates magnetic field source, which creates B vector. Okay. So I will say for whom you write the flux, you write the flux for the inner loop, and in which the current is flowing and magnetic field is created due to outer loop. In that case, you can directly say this M is directly proportional to area of the inner loop is going to be L square. Here, okay, I think I have to write this all alone once more. See, let me write it for you. Okay, again I am saying mutual induction is directly proportional to the area of the inner loop, okay, for which you are writing the flux by length of outer loop, which creates the magnetic field. This implies capital M is directly proportional to area of the inner loop is L square, outer loop is capital L. That's your answer. M is directly proportional to small l square by capital L. Okay. Remember here, inner loop for which you write the flux, outer loop is that loop in which you flow the current and which creates the magnetic field. Let's move on to the next one. Now, dimensions. Now, few of the questions are of EM waves. Dimensions of Poynting vector P are same as that of Poynting vector. What is a Poynting vector? Poynting vector is a S vector that gives 1 by mu naught E cross B, like this. So I will say its direction. I want you to remember this. Direction of Poynting vector is equal to velocity of EM wave propagation. As you can see, E cross B will also give you wave. And magnitude of Poynting vector is giving you the intensity of EM wave. Intensity can be written as power radiated per unit area or energy radiated per unit area per unit time. So power radiated per unit area, power's dimension is ml2 t minus 3 and area dimension is L2. You see L2 and L2 will be cancelled and the final answer will become, or you can say, are same as that of power radiated per unit area. They didn't ask you even the dimensions, but if they do ask, answer should be M1 L0 t minus 3. M1 L0 t minus 3. Okay. Achha, one more thing. Where do we use this? Where do we use this intensity or Poynting vector's magnitude? So I will say if there is a perfectly absorbing surface and if there is a perfectly reflecting surface and you incident a wave, okay, you are incidenting a wave, so with intensity I naught, suppose, so for perfectly absorbing, the radiant pressure is given by 1 times I naught by C. And here for perfectly reflecting, it will come as well as it will go back. So momentum changes twice, force experiences twice, the pressure exerted is also twice. So 2I by C. So Poynting vector is a very important vector whose magnitude gives you the intensity, direction gives you the direction of wave propagation associated with the EM wave we are talking about, obviously. And this intensity can be useful in dealing with many other aspects of EM wave. One of the examples is calculating the radiant pressure. But this is not the only thing. We have many other uses of that also. Alright, I want you to remember this. Next is a parallel plate capacitor of capacitance 20 microfarad is being charged by a voltage source whose potential is changing at the rate of 3 volt per second. So what is the data given to you? The capacitance value is given to you as 20 microfarads. The dV by dt data is given to you as 3 volt per second. They are asking you the conduction current through the capacitor wires and the displacement current through the plates of the capacitor. So can I say conduction current is always equal to displacement current here? Equation of continuity. Continuity of current. Continuity of current. Displacement current and conduction current are always equal, and that will be equal to dq by dt. So that will be equal to d by dt of C into V. So that will be equal to C dV by dt, because capacitance will not change with time, but voltage is changing with time. C value is 20 microfarads, dV by dt is 3 volt per second, and hence the answer is 20 into 3, 60 microcoulomb per second, or you can also call it 60 microamperes. So both are going to be 60 microamperes, and anyways, if you go for the option checking, field is changing, potential is changing, so definitely there is a displacement current. You can't take it zero. And if there is a non-zero displacement current, then there has to be a non-zero conduction current. So by option checking also, you will be getting option 2 only. Alright? I didn't start with option checking because I wanted to emphasize in front of you on continuity of current. But you can do that in the exam. A plane electromagnetic wave propagates along the x direction in free space. The components of the electric field E and B vectors associated with the wave in Cartesian frame are. I will say the formula governing for the direction is V equal to E cross B. Here you are telling us that V vector is, the propagation is along plus x axis, so plus I cap. So here this can be something cross something here, something cross something here. The two remaining directions options are J cross K and K cross J because of the transverse nature. So J cross A, K cross J. Just check which one is true. Which one is true? Do we have J cross A? Do we have J cross K is equal to I? See, I, J, K. J cross K is equal to I? Yes, correct. Do we have K cross J is equal to I? No, it has minus I. So you can see electric field is along the Y axis, magnetic field is along the Z axis. Electric field is along the Y axis, magnetic field is along the Z axis. If I try to draw the diagram in front of you, I will say X axis, Y axis, Z axis. So the wave is propagating like this in the positive X direction. Okay. So the electric field is oscillating in Y axis. The electric field is oscillating in Y axis, up and down, this is the electric field vector. And magnetic field vector is oscillating in Z axis in the same phase, like this is the magnetic field vector. This we commonly call it as a transverse nature of electromagnetic wave. Alright. Now that can come in the form of vector, that can even come in the form of the diagram. So if you notice, I have talked about the I cap, J cap, K cap as well as the transverse nature diagram, Cartesian diagram. Next. Next question is, given below are two statements, assertion, reason you have to talk about. Electromagnetic waves carry energy but not momentum. This is false here. If they don't carry momentum, then how did you how did you exert the force? How did we calculate the radiant pressure? We talked about the radiant pressure few minutes back, no? So whenever electromagnetic wave is falling on a surface that carries the momentum, exchanges the momentum, exerts the force, exerts the pressure. Okay. So saying this is false. Mass of a photon is 0. That's true. But then sir, if mass is 0, how it transfers the momentum? Because rest mass is 0. But whenever a photon starts moving, its dynamic mass is non-zero. So I will say assertion is false and reason is true. Assertion is false and reason is true. Its rest mass is 0 here. Easy. A plane electromagnetic wave of 20 mHz propagates in free space along the x direction, x axis, positive x axis we can say. At a particular space and time, E vector is equal to this. What is the B vector at this point? So let me write the equation of the direction first. I'll write V vector is equal to E cross B. Fine. So you are writing this V vector as it is moving in I cap along x direction. It is moving in I cap. This E vector is C. It is written in J cap. So what should be this direction? This direction should be J cross K. Just now we have commented J cross K. So how many options do we get for K cap, positive K cap? I think it is minus K cap, it is I cap, it is minus I cap, so it is my K cap. So the option 2 is correct. So the moment you see the question, you feel that no, it's a numerical problem, we start doing the calculations. But first of all, I strongly believe, as I said yesterday also, that once you say that we have read the problem, reading of a problem is completed only if you read all the options along with the question. So once you read the question, it's an objective exam, go through the options also, and after that you find that the reading is complete, then you start attempting. Okay na? Because many questions can be directly orally done also. So here the first book like NCERT part 1 of class 12th is completed. We emphasized, we have taken a lot of time to talk about many good models. Make sure you prepare and revise it nicely. This part 1 is actually the most scoring NCERT out of the 4 NCERT, 2 of class 11th and 2 of class 12th in NEET syllabus. Alright, the most scoring is just now what we have completed. Fine. So now let us start with the optics problems, ray optics, wave optics, followed by the modern physics. Chaliye. Now, two transparent media A and B are separated by a plane boundary. The speed of light is given to you and the critical angle for a ray for these media. So I will say the critical angle C can be written as sine inverse 1 by mu. So that can be written as sine inverse mu r by mu d, or that can also be written as sine inverse lesser velocity v low by v high, because sine can never be greater than 1. Sine can never be greater than 1, so it can never be high by low value. It can also always be low by high. So that will be equal to, this implies C will be equal to sine inverse. If you do low value by high value, 1.5 into 10 to the power 8 by 2 into 10 to the power 8 given in the question. So 1.5 by 2 is 0.75. So sine inverse 0.75 is your answer. Okay, sine inverse 0.75. Alright, let's move on to the next one. I'll keep solving it in front of you. I'll keep guiding you. You can adjust the speed accordingly, or else you can revise it thoroughly and take some time by pausing the video later on once the marathon is completed. What is the lateral shift of a light ray refracted through a parallel sided glass slab? It's the standard formula. The lateral shift D is given by T by cos R sine of I minus R. It's the standard formula, but it's a question expected this year. So I will say, just remember all the standard formula. It is H by cos R sine of I minus R. H by cos R sine of I minus R. In the detailed lectures, I have already shared the derivations and all these for like how the formula are coming. So today I won't talk about the derivations. I'll say when the formula is important, you remember the formula. When the tips are important, I'll keep delivering them. Next is a concave mirror of focal length f in air is dipped in a liquid. They are asking you the focal length of the liquid, focal length in the liquid will be. I'll say behavior of mirror doesn't change with surrounding medium. Although for lens, we say if you immerse it in water, its focal length, power, everything will change. So I will say, but for lens, we can write 1 by f will be equal to mu of lens by mu of surrounding minus 1 by R1 minus 1 by R2. So surrounding matters, lens material matters, shape also matters, but the behavior of mirror only depends on its shape. It doesn't depend on its surrounding medium. So hence the correct answer is, it was in the air, it was F. In the liquid also it is going to be F. Alright, let's move on. Basic properties, questions are easy. What is the relative decrease in focal length of a lens for an increase in the optical power by this from this? So D stands for diopter. Okay, so I will say P initial, optical power initial is equal to 2.5 diopter this implies focal length initial is equal to 100 by 2.5. So that will be equal to how much? Or 1 by 2.5, if I'll do 100 by 2.5 is 40 centimeters. 40 centimeters I got. Okay. P final is equal to, you increase by 0.1 d. So it is 2.5 d. I mean, it is P initial plus 0.1 d. So that is 2.5 plus 0.1, that is equal to 2.6 d. 2.6 d. All right. So F final will be equal to, or just you can write it as 100 by 2.6 is equal to some centimeters. So what they are asking you finally is the relative decrease in focal length. Relative decrease in focal length. Relative decrease in focal length. Decrease or loss is always initial minus final. So F initial minus F final by F initial. If they ask percentage, so I will multiply it with 100. So F initial is how much? That is, you can say 1 by 2.5 in terms of meter if you want to get, or you can also say 40 centimeter like that. Standard way you can do it like this: 1 by 2.5 minus 1 by 2.6 by 1 by 2.6 like that. So what it is exactly? It is 2.6 minus 2.5 by 2.6 into 2.5 by 1 by 2.6. So you see this term and this term is cancelled. So 2.6 minus 2.5 is 0.1 by 2.5. So that is 1 by 25 or 0.04. And hence the correct option is 0.04, first option. All right. This is a nice question for this year. I mean, the question is easy. P is equal to 1 by F, like that way we are doing, but just have a look of the process. I would like you to take the screenshot also parallelly. The notes will also be shared later on. All right, let's move on to the next one. A prism is made up of material of refractive index square root 3. The angle of the prism is A. If the angle of minimum deviation is equal to the angle of the prism, then the value of A is, if angle of the minimum deviation, del minimum, is equal to the angle of the prism A, and what they are saying, calculate the value of A. So I can use this mu, which is root 3, that is equal to sine of del minimum plus A by 2, del minimum plus A by 2 by sine of A by 2, and this thing is given to you here. This is given that del minimum is equal to A. So if I try to solve it, I'll write it as root 3, that will be A plus A, I mean 2A by 2, A plus A, 2A by 2. So sine of 2A by 2 means sine A, and it is sine of A by 2. Or else what I can do is, this can be written as 2 sine A by 2 cos A by 2, and in the denominator you have it as sine A by 2. Alright. So what you can see, sine A by 2 is cancelled. That 2 in the numerator can be brought here. Root 3 by 2 will be equal to cos of A by 2. So root 3 by 2 is the value of sine 60, but it is the value of cos 30. So you will say 30 degrees will be equal to A by 2. This implies A will be equal to 60 degrees. A will be equal to 60 degrees, and see, that's your answer. A is 60 degrees. Alright. Either you do it this way, or you do it this way entirely, or else what you can do is check the options here. I mean, it is also easy. If you put 30 here, so 30 plus 30, it's 60 by 2, and then it is 30 by 2. You can just put the values and do the option checking. The only trouble could be that if it is 60, so 60 by 2, 30, you can know, like you easily know the values of trigonometric function. But if you check for 30, 30 by 2 is 15 degrees. You don't know that value. 45 by 2 is 22.5 degrees. You don't know that value. So if this thought is coming in your head that we would have done option checking, sir, despite all this, then I'm telling you option checking is not so easy. You have to do some trigonometric modification here. Okay, that's why the basic trigonometric identities are required to be remembered. Okay, let's move on to the next one. Next is a convex lens made of glass whose refractive index and focal length is given to you. When it is totally immersed in a water, I just now a few minutes back I told you that lens behavior depends on the surrounding. They are asking its focal length changes to. Its focal length changes to. If they ask changes by, which means they are asking the change. If they say changes to, which means they are asking the final value. Final value. है ना? Changes by means what is the change? Changes to means final value. So if I am writing here 1 by f initial, that is equal to 24, and that is mu of lens with respect to surroundings. So 1.5 minus 1 minus 1, 1 by r1 minus 1 by r2. Anyways, that shape governing term will not change. 1 by f final, which they are asking, when you are keeping it in between, when you are keeping it immersed in 1.33, 1.33 minus 1, 1 by r1 minus 1 by r2, like this. I would suggest you to divide it here. The moment you will divide, you will get this cancelled, and what you are having here is f final by 24, and that will be equal to, numerator is having 1.5 minus 1, that is 0.5, okay, and denominator is having here 1.5 means I'll write it as 3 by 2, and 1.33 means I'll write it as 4 by 3 minus 1, okay. So because maybe sometimes dealing with the decimal is complicated for us. So f final is equal to 24 will be multiplied with 0.5, and here it is denominator will become numerator, so it is 9 by 8, 9 by 8 minus 1. So what you got is 24 into 0.5 is 12, by 9 by 8 minus 1 is basically 1 by 8. So denominator 8 again will become the numerator. 12 8 is 96, I think, 96 centimeter. 96 centimeter. That's your answer here. Option 2. Basic calculation, I would just say, you may also try to think about the formula, sir. If it is a convex lens given, why you are not applying the formula r by 2 mu of l by s minus 1? I could have applied the same. But I already knew that if you are comparing two cases of focal length, anyways this shape governing term will get cancelled. Whether you write it as 2 by r by 2, 1 by r1 minus 1 by r2, during the comparison or ratio, it will automatically get cancelled. Next is two identical symmetric double convex lens. It is a problem based on cutting of the lens. The ratio of focal length of lenses L1 and L3. Now see, if you cut it this way, like parallel to the principal axis, P final still remains P initial, P naught, and F final still remains F naught. But if you cut it this way, you make a plano-concave or a plano-convex lens, P final dash, power becomes half, and F final dash, focal length gets doubled to F naught. So what they are asking you in the question is the ratio of focal length of L1 and L3, F1 by F3. You see F1 is this, F1 is F naught, and F3 is the second case, that is 2 F naught. So hence the focal length ratio is 1:2. 1:2. That's your answer. Easy. Let's go for the next one. A light ray enters through a right-angled prism. Right-angled prism, the angle A is 90 degrees. Symbolically, it is also mentioned, right? Right angle there. With the angle of incidence 30 degree as shown, it travels through the prism parallel to its base and emerges out along the face AC. This situation is called as grazing emergence. Along the boundary coming out, that situation is called as grazing emergence just before the situation of TIR at this surface is attained. Before the TIR, grazing emergence. Critical angle will be formed here. They are asking you the refractive index of the prism. So can I say at this point, I can write R2 is equal to critical angle as and angle of emergence is equal to 90 degrees. Can I say at this point, R1 is equal to A minus R2. So that can be written as 90 minus C. Because angle A is 90 degrees and R2 is equal to critical angle, and this is angle E, angle of emergence. So if you are trying to apply the Snell's law here, you will write 1 into sine 30 degrees, that will be equal to mu into sine of R1. So that will be equal to mu sine of 90 minus C. Sine 90 minus C is cos C. Cos C can be written as under root में 1 minus sine square C. Again this is mu under root में 1 minus 1 by mu square. If you take the LCM, after taking the LCM, mu in the numerator and mu in the denominator will be cancelled, and we will be having under root of mu square minus 1. Okay. From here what you can say? Under root of mu square minus 1 on that side, it is sine 30 degrees. Sine 30 degrees is 1 by 2. Square both sides. Mu square minus 1 is equal to 1 by 4. 1 can be sent on that side. Mu square is equal to 5 by 4. 1 plus 1 by 4. This implies mu is equal to under root of 5 by 2. Under root of 5 by 2. I think option 2 is correct. So this is a question that is based on the basic Snell's law, but also the approach of grazing emergence or TIR condition. You have seen this being done in the optical fiber topic also, as well as the TIR. Alright, optical fiber itself is an application of TIR. Next is optical instruments. For optical instruments, people are generally struggling and not liking that much the topic, but I always say that irrespective of your likings and dislikes, you must be remembering all the NCERT formula, must memorize all the NCERT formula and also their symbolic significance, what different symbols are denoting. For example, let us see. An astronomical telescope has an angular magnification of magnitude 5 for distant objects. The separation between the object and eyepiece is 36 and final image is formed at infinity. Final image is formed at infinity means which type of adjustment? Normal adjustment. Normal adjustment. In case of normal adjustment, the magnification magnitude is given by FO by FE, and that is equal to FO by FE, and that is equal to 5. FO by FE is 5. Also the length of telescope in this case, which is the separation between them, FO plus FE is equal to, FO plus FE is equal to 36. So I will be using both of them. Length of telescope is equal to, because length of telescope is adjustable, no? Variable. Length of microscope is fixed. That is FO plus FE. So that is equal to 36 centimeters. So we can check both of them. Let us check when it is 36 and when it is not 36. 45 minus 9. But both are convex lens only, no? Okay. And also you can check FO by FE is 5. So FO by FE is 5 and both are convex lens. They are writing it negative. They should be taking it positive only. Anyways, FO by FE is here 5, FO by FE is here 5, FO by FE is here 5, but the sum of these two in magnitudes is going to be 36. I'll select this one. Sum of these two in magnitudes is equal to 36, and here also is going to be this modulus. Alright. So this is the way. If you even remember the basic NCERT formula, you can directly do the option selection. Derivation is not required for NEET exam. Okay, if you can understand and remember, that's fine. But if something seems tough for you, then at least you can, you can be remembering the NCERT formula and accordingly you can answer. I'll go ahead here with the next one and the last problem of ray optics. After this, we will take the wave optics problems also. A plano-convex lens of refractive index 1.5 and radius of curvature 30 centimeter is silvered. So at the curved surface. So it is silvered at the curved surface, which means it is equivalent to a convex lens plus a concave mirror plus again the convex lens, and this time you want the F equivalent first of all, or power equivalent, standing in air. If you want the equivalent focal length or power to be calculated with reference to air, relative to air, which means the individual values must also be entertained with respect to air. I mean, you don't apply the formula lens immersed in liquid here or mirror kept in the lens here. No, not like that. Okay. So the lens is used to form an image of an object. At what distance from the lens an object is to be kept to have a real image of the same size? Object size is equal to image size. Object and image are coinciding. Object and image are coinciding or formed at the same location. Light rays retracing their path. These three problem statements, these three languages of question means the same. Light rays retracing the path means effectively the normal incidence. I would say these three languages means the same. If that means the same in this question, then I will say the effective distance will be equal to 2f equivalent for the same. You know, if the object is kept at C, the image is also at C, but this time that distance of C 2f will change because there is not a single focal length which you are entertaining, but there are four different focal lengths for us. So let us do the same. So I will say here power equivalent which is 1 by F equivalent will be equal to P of 1, like this is P1, this is P2, this is P3. All are converging, so this must also be positive, this must also be positive, this must also be positive. How sir, it's a concave mirror, focal length is negative. So power for the lens is 1 by F, but power for the mirror is minus 1 by F. So this is P1 plus P2 plus P3, out of which P1 and P3 are same. So P1 formula is like you can write it as twice of positive of 1 by focal length of lens plus power of mirror is minus of 1 by focal length of mirror. Okay? Minus 1 by power of the mirror is given, not given by 1 by F, it is given by minus 1 by F. Okay? And this refractive index is 1.5 and the radius of curvature is 30. So let me write it for you. Here F1 is equal to F3 is equal to positive of R by 2 mu of L with respect to S minus 1. So that is 30 centimeter, right? So positive of 30 by 2 of 1.5 minus 1. So 1.5 minus 1 is 0.5 into 2 is 1. So answer is 30 only. And F2 will be equal to minus of R by 2. So minus of 30 by 2, that is minus 15 centimeters. Minus 15 centimeters. So I'm solving this question here now. So P equivalent, which is 1 by F equivalent, will be equal to twice of positive of 1 by this 30 you can write. Okay, but that is in centimeters. So I will write it as 100 by 30 there. One by 30 like this plus minus of this is minus 15. Minus will become plus here. So I suppose that is 2 will cancel this 30, it is 1 by 15 minus plus it is how much? 1 by 15, 1 by 15 plus 1 by 15 is 2 by 15. Just check it once. R by 2 you are getting. So minus it should be plus. Focal length of the mirror is 30 by 2. 30 centimeter is silvered, right? Okay. And what next? Okay. So that will be equal to 1 by 15. 1 by 15 can I directly do here? 1 by 15, 1 by plus 1 by 15 is 2 by 15. So this implies F equivalent will be equal to 15 by 2 centimeters. Is it 15 by 2? Okay, but we required, no. Okay, just leaving this last step calculation for you. After solving this, just have a look. What did we? It was a plano-convex lens here. It was a plano-convex lens. I did it wrong at the start. My bad. Plano-convex it is. Plano-convex it is like this. So this 2 will not be available here. 2 will not be available here. This will be 60. Yes, now we got it. Okay, this is 60 here. So power is 1 by F equivalent. Now I will be writing. I think everything else is same. Okay. So power is 1 by F equivalent, that is equal to twice of what you got over here is positive of 1 by 60 and plus minus of by minus 15. So now what you got here is 2 into 1 by 60 is 1 by 30 minus minus plus 1 by 15. Okay. Or you can also write it as, I can write it as 2 by 30. So 3 by 30 or 1 by 10. Please keep checking. Therefore, X distance required was twice of F equivalent. I think take the reciprocal both sides. I suppose 20 centimeter. Please check the calculations. Oh, it's been so many hours. The marathon is going on. Just check it here. I think 20 centimeter will be the answer. Have a look of the calculation, then we'll move ahead. So this completes the ray optics discussion also. Now few more problems in which we are going to target. We are going to target the atoms, dual nature, nuclei. So 40 more problems, almost uniformly bifurcated. Wave optics 10, dual nature 10, atoms, nuclei 10 and semiconductors 10. Make sure you watch that in continuity. I think we are comfortable now. So now let's start with the discussion of wave optics. In a Young's double slit experiment, when light of wavelength 400 nanometer was used, the angular width of the first minima is found to be 0.2 degrees. What will be the angular width of the same first minima if the entire apparatus is immersed in water? So we know that lambda in medium is equal to lambda in vacuum by mu, right? Lambda in vacuum by mu. We also know beta is equal to lambda d by d and theta is equal to beta by d, which means lambda by d. So clearly we can say theta is directly proportional to lambda. This implies that is what we can conclude here is beta is also directly proportional to lambda and theta angular width is also directly proportional to lambda. So theta in medium is also equal to theta in vacuum by mu, right? Theta in medium is how much given to you? Theta in vacuum is how much given to you? 0.2 degrees and the mu of the medium in which you are immersing is 4 by 3. So that will be equal to denominator 3 will go into the numerator. 0.2 into 3 is 0.6 degrees by 4 it is 0.15 degrees. 0.15 degrees, that's your answer. 60 by 4 is 15. Easy that is. Basic formula. Next is a parallel monochromatic beam of light is incident normally on a narrow slit, single slit. It has to be diffraction. Oh, they are mentioning it also further. A diffraction pattern is formed on a screen placed perpendicular to the direction of the incident beam. Let us draw the diagram parallelly. So this is the situation. This is M, this is N, okay? And a monochromatic beam of light, a parallel monochromatic beam of light is coming, which means I can draw it as the incident wavefront. Plane, these are the light rays. So I can mention plane incident wavefront. Plane incident wavefront, the basic diffraction I'm explaining. So here at the first maximum of the diffraction pattern, the phase difference between the rays coming from the edges of the slit is first maximum. I think they should be asking you the first minimum if the answer has to be 2 pi. Okay. They are asking you the phase difference here. Anyways, chalo, I'll explain it to you. This is the screen. Okay. I think they must be asking you the minimum. First minimum. Let us see. Let us analyze for minimum and maximum both. Let us talk about the minimum first. So can I say this is the central maxima here? At the first minima, suppose at the first minima we are talking about. So if a wavelet is coming from the upper region of this, I have kept a divider here, S divider. So at the place of first minima, if a wave coming from the upper region of MS and from the upper region of SN, it superimposes, they have to destruct each other for minima. So the phase difference is supposed to be pi, right? Cos pi is -1. Phase difference is supposed to be cos pi here. Here between these two, the phase difference will be pi. Okay. If you consider the bottommost region of MS and bottommost region of SN, which means these are wavelets are rising from here and reaching here. Here the phase difference between them is also pi, which means corresponding to each and every point available in the MS region, there has to be, this language is given in NCERT. Corresponding to each and every point in MS region, there has to be a point in SN region which will have a phase difference of pi. What did they ask? They asked you the diffraction pattern, the phase difference between the rays coming from the edges of the slits. So if between M and S, every time there is a phase difference of pi, between S and N, every time there is an additional phase difference of pi. So the phase difference overall in these two, the phase difference overall in this and this here is going to be 2 pi. Phase difference is going to be 2 pi. But this is the conclusion when you are getting here what? First minima. That's why I said that in the question, instead of maximum, they must be asking the minimum. I could have used some formula and explained you that way, but I took it as an opportunity to discuss the NCERT theory. If you haven't read the theory of the diffraction given in the NCERT wave optics, after this discussion, I would suggest you take 10 minutes. Remember my language, or listen to this video at this point once again before reading that half or 1 page of NCERT. After listening to my words, when you will read it, you'll be finding it very easy to understand. Okay, let us move ahead. Next is, if a thin mica sheet of thickness T, refractive index is given as placed in the path of one of the interfering beam, then the displacement of the fringe system is, I'll tell you, additional path difference. If I talk about the formula of fringe shift, the fringe shift formula is given by mu minus 1 into T, d by d, or mu minus 1 into T, where T is the thickness, beta by lambda. I'm just telling you, number of fringes shifted, number of fringes over which the system, the pattern shifts, that will be equal to shift by fringe width, beta. So that will be equal to mu minus 1 into T by lambda. But in this question, they are only asking you the shift, the fringe system shifts by. So I will say shift will be equal to, formula we can apply, mu minus 1 into T. So it is 5 by 3 minus 1 into T. T is the thickness. You need the answer in terms of thickness only. 5 by 3 minus 1 into T, capital D by D. And you want to hear capital D by D also as it is. Capital D by D also you want as it is. So 5 by 3 minus 1, that's no doubt 2 by 3 dt by small d. Okay. 5 minus, so 2 by 3. Okay. What I have missed? Lambda d by d, then the displacement of the system is, okay. So what they have changed in the question is, generally we take the slit separation as d, but here the slit separation d equivalent is equal to 2d. In fact, be careful because this time the options were not available. So I could reach the options, but if the both options are available in the exam, then who knows, even I would have done this error of selecting the standard formula. But here this is d equivalent, which is given in the question, as 2d in the diagram. So that will be equal to 2dt by 3 into 2d, and hence the final answer will be dt by 3d. dt by 3d. Third option is correct. Second option. Option B is correct. I hope that's clear. This was the tricky part in the question. But I am telling you, we have understood, we got the idea that it is a tricky part or a common mistake because we didn't get any option matching. But if that, like the initial option which we were getting, that is also available and this is also available, then we need to be very cautious here. Okay, chaliye, let's go on for the next one. Assertion reason. We know diffraction of light waves is not so common, but diffraction of sound wave is common. The reason is sound waves, diffraction is much more pronounced when the size of obstacle or aperture is comparable to the wavelength. Light waves have the wavelength range of 400 to 700 nanometer roughly, which is very small. And the size of common obstacle, aperture, windows, shades, these are not in the order of 10 to the power -6 or -7. So in short, since the size of common obstacle or aperture is not comparable to the wavelength of light, so wavelength of light is not so commonly observed in daily life. But sound waves which have much more longer wavelength, that wavelength and the size of common obstacle or aperture is roughly of the same order. So you can say sound waves diffraction can be easily experienced and observed in daily life. Similarly, this assertion is based on radio waves and microwaves. Microwaves, as the name itself suggests, they have the wavelength of micro order, 10 to the power -6 meters, and the size of common obstacles or apertures, those are not of that small range. So microwaves are not so easily diffracted, but radio waves having much more longer wavelengths can be easily diffracted. So out of the radio waves and microwaves, the former means the radio waves, later means the microwaves. The former undergoes more diffraction. That's true. Okay. Radio waves have greater frequency, false. They have greater wavelength. Lambda of radio waves is much greater than lambda of microwaves. And since lambda is greater, that's why diffraction is much more pronounced. So assertion is true, but the reason is false. Alright. NCERT talks about the example of light and sound. They have framed a problem on the basis of radio wave and microwave, but logic hidden is same, no? Next is the maximum intensity in Young's double slit experiment is I0. This is a problem model, already a PYQ, which gives you the basic idea of a transition which you take from, location to path difference to phase difference to intensity. Location to path difference, you have y is equal to delta x capital D by D. Path difference to phase difference, you have phi is equal to 2 pi by lambda into delta x. Intensity and phi, you have I is equal to I max cos square phi by 2. Okay. So I'll be talking about this transition. Let's talk about the question once. They say what will be the intensity in front of one of the slits? In front of one of the slits, it's a basic YDSC apparatus. A few relations between the parameter is given to you. I didn't read those relations because with the passage of time, whenever I'll be needing some information, I'll reread the problem. And what they are saying majorly in the question is in front of one of the slits. So if you try to draw, this is slit 1 and this is slit 2, and this is the location of central maxima on the screen. The distances are always taken from here. In front of one of the slits at this point, this distance from central maxima y is equal to d by 2, because the total slit separation is d and the distance between the slit and the screen is capital D. Okay. So in front of one of the slit, the separation from central maxima is exactly d by 2. So step 1, I will say here that y, which is equal to d by 2, that is equal to delta x capital D by small d. See, this capital D is given as 10d. Capital D by small d, let me write it this way. This implies delta x is equal to d square by 2d. d square by 2d. Now write this d square 2d. 2 capital D can be written as 10d. So that is d by 20. Now write this d as 5 lambda, right? It is given here. So that is 5 lambda by 20. This implies eventually you got delta x as lambda by 4. You got this. Now phase difference. Phase difference is equal to 2 pi by lambda into delta x, that is lambda by 4. So that is equal to pi by 2. Now intensity. Finally, I'll write the intensity. Finally, intensity is equal to I max cos square phi by 2. That means pi by 2 by 2. So that will be equal to I naught. I naught is not the single one. I naught is the central maximum intensity. Intensity of central maxima is I naught. So that is I naught cos square pi by 4. So that is I naught cos pi by 4 is 1 by root 2 and its square, and hence the final answer is I naught by 2. Final answer is I naught by 2. So yes, this problem is a time taking problem, but if you see all the steps of YDSC, in short, we have covered location to part difference to phase difference to intensity. Have a look. All right. Chalo. Let's move on to the next one. Two Polaroids P1 and P2. Now some problems are based on polarization. Two Polaroids P1 and P2 are placed with their axis perpendicular to each other. Unpolarized light I naught is incident on P1. So they have perpendicular. I mean, this is P1, its axis is this. This is P2, its axis is this. The total angle from here to here is 90 degrees. Theta is equal to 90 degrees here. Unpolarized light I naught is incident on P1. This is ordinary light. Unpolarized light, ordinary light, whose intensity is I naught, that is, incident on P1. So outer one will be the plane polarized light. Outer one will be here the plane polarized light, PPL, whose average intensity I dash will be half of the initial intensity because of the average value of cos square phi and law of Malus. A third Polaroid P3 is kept in between P1 and P2 such that its axis make an angle of 45 degrees with that of P1. So now you introduce a third Polaroid P3 such that its axis is making an angle 45 degrees with that of P1. So if this theta 1 is equal to 45 degrees, then can I say the next theta 2 is also 45 degrees? Because overall they were crossed means 90 degrees. So now if with the previous one it is making 45, so definitely with the next one also this P3 axis will make an angle of 45. Alright. Now what they are asking, the intensity of the transmitted light through P2. They are asking you what is available here. What is intensity? I dash. Okay. So I'll be writing it this way here. I dash will be equal to, I final will be equal to, first of all, which intensity you had? I naught. Okay. Now what did Polaroid 1 do? Polaroid 1 made it half. Polaroid 1 made this intensity half. Why, sir? Because whenever ordinary light changes to PPL, it gets halved only in intensity. Next Polaroid, what it will do? It will do cos square 45 degrees. And next Polaroid, what it will do? It will again do cos square 45 degrees. But there are three Polaroids. First one Polaroid did it half. Second Polaroid did it cos square 45 degrees. Third Polaroid again did it cos square 45 degrees. Basically cos square theta 1 and cos square theta 2 according to law of Malus. So that is I naught 1 by 2 cos square 45 1 by root 2 square 1 by root 2 square. So it's 1 by 2, 1 by 2 and 1 by 2. Final answer is I naught by 8. Alright. So the answer will be I naught by 8 over here. Is that clear? Going for the next. Yeah. So that's a NEET PYQ. It's already a NEET PYQ, but a good problem. So I will explain it to you. An unpolarized light is incident. Now, if it is already a NEET PYQ, exactly this might not come, will not come for sure with the same set of options. But we need to understand each and every option so that if a similar problem or a related to any option they ask, you should be able to answer it. Unpolarized light is incident from air on a plane surface of a material of refractive index mu. So this is air that can be taken as mu r, and this is denser medium, say mu d, and unpolarized light is coming. So when polarized light comes, it has the vibrations here, all the planes. Which vibrations we talk about? we talk about electric field vector vibrations, है ना? This is incident light, ordinary light. Now, at this point of incidence, normal to the point of incidence, okay, and the reflected and refracted ray will be there. So you will say the reflected ray RR can be polarized, and if it is incident at polarizing angle, particular angle I, this is 100% polarized, 100% polarized if I is equal to polarizing angle, and Brewster's law, like previous question was based on law of Malus, this is based on Brewster's law. It is tan inverse mu, tan inverse mu 2 by mu 1. So here it will be tan inverse mu. Okay. So this angle is supposed to be polarizing angle in that case. And if we talk about the refracted ray at polarizing angle, the reflected and refracted ray must be perpendicular to each other, RR dash. So its vibrations, if we show, you know, you would have observed it that in all the books, everything, they show this vibration. What do you mean by this vibration? These dot vibrations are perpendicular to the plane of incidence. This plane which you are talking about, no? This plane here, okay, this plane here in which I am drawing the diagram, this plane is called as plane of incidence. Plane of incidence. And if we talk about the refracted ray, it is never 100% polarized. It is never 100% polarized. It is always partially, you can say. So it will have vibrations here also, dot also, here also, like this. So what we can conclude is at polarizing angle, RR and RR dash will be perpendicular to each other. Reflected ray will be 100% polarized. That value of polarizing angle is tan inverse mu. And the vibrations in the reflected ray will be perpendicular to the plane of incidence. They will be in the plane of vibration or plane of polarization, but they will be in the perpendicular to the plane of incidence. And hence, a reflected light is polarized with its electric vector perpendicular to the plane of incidence. And we were searching for tan inverse mu, but it is tan inverse 1 by mu. That is also not correct. I hope this is clear. All right. Chaliye, let's move on to the next one. The interference pattern is obtained with two coherent light sources. Why coherence is necessary? So that the interference will be sustained. Okay, sustained interference pattern, coherent sources must be there. If the interference pattern intensity ratio is n, they are asking the ratio of Imax minus Imin by Imax plus Imin. So I'll directly start doing the problem here. See, Imax minus Imin by Imax plus Imin. This Imax can be written as root I1 plus root I2 whole square minus root I1 minus root I2 whole square by root I1, I mean by the same thing plus the same thing here. Okay. Now see, it is a plus b whole square minus a minus b whole square. So it is 4ab root I1 root I2. And it is a plus b whole square plus a minus b whole square. It is twice of a square plus b square. Twice of a square plus b square. So this 4 will be cancelled by 2. It is 2 here. And it is under root of I1 I2. Under root of I1 I2 by I1 plus I2. Let us divide the numerator and denominator. Divide numerator and denominator by I2. So that will be equal to twice of root I1 by I2 by it is I1 by I2 plus 1, because I2 by I2 will be 1 only. Okay. So this I1 by I2 is given to you as the intensity ratio, individual intensity ratio as n, and hence the final answer is 2 root n by n plus 1. 2 root n by n plus 1. I think third option will be there. Okay, you can go through the calculation once. All right, let's talk about the next one. Right, another certain reason for us, why DSC? In Young's double slit experiment, the fringes produced by red light are closer as compared to those produced by blue light. It is false. Solved NCERT example. Solved NCERT example. And as of now, to explain that, so I'll suggest you after this marathon session, definitely go through all the parts of that solved NCERT example. All parts. Okay, you'll understand what I'm talking about. It gives the explanation also. I can also explain, but I want you to go through it, right? Next is the fringe width is directly proportional to the wavelength of light. Yeah, that is true. The fringe width, just now I have told you that beta is also directly proportional to lambda, and even theta is also directly proportional to lambda. So I will say assertion is false, but reason is true. And there is as such no relation between the two. Okay. Next. The Young's double slit experiment, I think it is the last problem of wave optics. Then we will switch on to the problems of dual nature 10, atoms nuclei together 10, and semiconductors 10. So the Young's double slit interference experiment is performed using light consisting of 480 nanometer and 600 nanometer. The least number of bright fringes of 480 that are required for first coincide with the bright fringes of 600. So you want the Y max of lambda 1 to coincide with Y max of lambda 2, because you need bright and bright of both. If they say bright of the first and dark of the second, then one's maxima will be equated to another one's minima's location. So location of maxima is n1 lambda 1 d by d. So n1 lambda 1 d by d must be equal to n2 lambda 2 d by d. You can say this d by d will be cancelled. n1 lambda 1 is equal to n2 lambda 2, which means n1 by n2 is equal to lambda 2 by lambda 1. That lambda 2 by lambda 1 is basically 600 by 480, 0 cancelled, or 12 5s are 60, 12 4s are 48, which means the value of n1 is going to be 5 and the value of n2 is going to be 4. What they are asking now? They are asking the least number of bright fringes of 480. They are interested in the value of n1, which is 5. The least number of bright fringes of 480 that are required to coincide with any bright fringes of 600. So the answer is going to be 5. Okay. If they ask the least number of fringes of 600, which means that is n2, that will be equal to 4. I hope that's easy. Okay. So now we have to start with the problems of dual nature. I hope we are comfortable till now, right? Some more time and then successfully we will be completing all the 100 predictable problems. Make sure you revise it thoroughly. A proton of mass mp has same energy as that of photon of wavelength lambda if the proton is moving at non-relativistic speed. Doesn't matter. I mean, that useless for us. Why it is useless for us? Because we anyways don't study the theory of relativity. We all talk about we in our NEET syllabus always talk about the non-relativistic only. Then ratio of their de Broglie wavelength, ratio of its wavelength, proton to photon they are asking, and energy is allowed to be there in the expression. So I'll write energy of proton is same as the energy of photon. So energy of proton is equal to half mv square or p square by 2m. है ना? P square by 2m. चलो. What they are asking is ratio of de Broglie wavelength of proton to the de Broglie wavelength of photon. So de Broglie wavelength of proton h by mv. So h by under root of 2 mp kinetic energy E. Okay, h by mv or h by p, h by under root of this, and E is equal to hc by lambda. So lambda is equal to hc by E. Lambda is equal to hc by E in the denominator here. I think h and h can be cancelled. So denominator will become numerator. That's E by C under root of 2 mp into E. So this E will also be cancelled by root E times. I suppose 1 by C under root of E by 2 mp should be your answer. 1 by c under root of E by 2 mp. As I can see, third option is my answer. You can even check the calculation here. I have just simply applied the de Broglie wavelength formula for both of them. Alright, let's go for the next one. 72. When two monochromatic lights, okay, so when this question came, this is a NEET P by Q. This is a NEET P by Q. What is so special regarding this? It is mathematically solvable. Mathematically solvable, but conceptually wrong. Now, why it is conceptually wrong? Because in the question, they are telling that when the frequency is V, the stopping potential is less, and when the frequency is less, the stopping potential has increased. How it can happen? Stopping potential is linearly dependent on the frequency, no? So if frequency will keep on increasing, the stopping potential must keep on increasing. But here the frequency is reduced, the stopping potential is increased. So that is conceptually wrong. Let me do this problem for you. So I will say what they are asking is frequency of this, threshold frequency of this metal. So h nu will be equal to h nu naught plus, and you need the answer in nu. So that will be EVS by 2. EVS by 2. But remember, all the four, neither the question is to find out the VS nor the options are in terms of VS. So what I'll do is I'll isolate EVS here. That will be equal to 2h nu minus nu naught. Why we are isolating this? Because it is neither the required one nor the given option. Next is h nu by 2, and that is equal to h nu naught plus E Vs. From here, the value of EVS is equal to h nu by 2 minus nu naught. Okay. So from equation 1 and 2, LHS you can say that it is same. So RHS must be 2h nu minus nu naught will be equal to h nu by 2 minus nu naught. See, h and h is cancelled. Open the bracket, 2 nu minus 2 nu naught, that will be nu by 2 minus nu naught. If you send this term here and take this term here, 2 nu minus nu by 2, that will be 2 nu naught minus nu naught. Negative nu naught will become positive. So 2 nu naught minus nu naught is nu naught, and that will be equal to 2 minus 1 by 2 is 3 by 2. So it is 3 nu by 2. Mathematically, it is 3 nu by 2. Threshold frequency is 3 nu by 2. But you know what? If it is 3 nu by 2, then even if you are incidenting nu, if it is 3 by 2 nu is the minimum demand, then even if you are incidenting nu or you are incidenting nu by 2, how the photoelectric effect can happen? Photoelectric effect will happen only if you incident a higher wavelength, no? So this is not an authentic problem, but still, since this has already come in the exam, if I don't tell you, then you might be confused in this. Okay, that's why I have taken it for you. But I'm hoping that NEET doesn't do this kind of blunder ahead in the upcoming years, and they ask you some relevant problem and logically existing problems that can happen practically. Chaliye, I hope that is clear to you, both the ideas. Let's move on to the next one. In an experimental study of photoelectric effect, the stopping potential increases with, stopping potential only depends on the incident frequency, laws of photoelectric effect. So you will say the stopping potential only increases with increase in frequency of light. And what will control the, what will be controlled by intensity of light? Current will be increased. Saturation current or current will increase by this. Increase in the work function Ke max and stopping potential V naught both will decrease. Decrease in intensity of light, current will decrease. Okay, so we haven't only selected the correct option, but we have also seen what will happen because of the other modifications. Let's move on to the next one. Next is the energy and momentum of a moving body of mass m are related by some equation. Given that the c represents speed of light, identify the correct equation. Many of you have never seen any formula like this in physics. Many of you have never seen this formula. And if you look at the options carefully, then you will realize that dimensional analysis must be used. Dimensional analysis must be used to choose this. What is the use of dimensional analysis here? Principle of homogeneity. Only those two quantities can be added or subtracted which have the same dimension, and even after the algebraic operation of addition and subtraction, the final quantity must be having the same dimensions. Alright, so what we can see here, energy E is equivalent to P into C is equivalent to mc square. Squaring both sides, E square is having the same dimension of P square, C square is having the same dimension of m square c to the power 4. M square c to the power 4. So E square, that's why I had to do the square. P square, C square and m square c to the power 4. See, check for option 4. E square, P square, C square and m square c to the power 4 all will be having the same dimensions. I hope that's clear. Easy. So if a very different question comes which you have never heard, which you have never seen in your syllabus, then definitely there will be some way out of doing those type of problems in the exam. Next question is, in photoelectric effect, the stopping potential versus frequency curve is plotted. Stopping potential versus frequency curve. Let me do it side by side for you. So h nu will be equal to phi naught plus Ke max, which can also be written as EV naught. है ना? So from here, V naught will be equal to h by E into nu minus phi naught by E. If you compare it with y equals to mx plus c, so you will realize that if we draw the stopping potential versus frequency graph, it should be like nu or f. It should be a straight line graph. This is nu naught here. Its slope, if it is theta, then slope m is equal to tan theta is equal to h by e, and this y-intercept is basically phi naught by e. Y-intercept is phi naught by e. Let's see. Multiple options correct are there here. Multiple options are correct. Let's see one by one. Nu naught versus v is linear. True. The slope of nu naught versus v curve is h by e, phi naught by h. False. Slope is basically h by e. H constant is related to the slope of this line. True. And work function is related to the y-intercept. The value of electric charge of electron is not required to determine the h using the curve. It is required here. It is false. I mean, the slope will give you h by e. If you want to get the value of Planck's constant, you will be needing the value of E, no? That is electronic charge. The work function can be estimated without knowing the value of h. Yeah, for the work function, you need to know the y-intercept. You don't need the slope or h. So this is also true. I think even things are true. A, C, E are true. B and D are wrong. A, C, E are true. A, C and E only are true. They are asking true, right? Yeah, correct. Because generally in statement form, you should also see whether they are asking you the correct ones or the incorrect ones. I think you agree with this. Let's move on to the next one. K1 and K2 are maximum kinetic energies of photoelectrons when the wavelength are lambda 2 and lambda 1 incident on a metallic surface. If lambda 1 is equal to lambda 2, I think they should say, okay, they have played a trick in the language. K1 with lambda 2 because they are using the term respectively. So K1 is the energy when you are incidenting lambda 2. K2 is the energy when you are incidenting lambda 1. I think there is a error in the typing of the question, but assuming the question to be correct, first of all, let's do whatever they say respectively in the sequence. So I will be saying, it might be a confusing of 2 and 1 relating together, so be a bit careful. Hc by lambda 2, that is equal to phi naught plus K1, and Hc by lambda 1, which is thrice of lambda 2, that is equal to phi naught plus K2. So This implies hc by lambda 2 into 1 by 3, that is equal to phi naught plus k2. This implies phi naught plus k1 by 3. From the first one I have substituted, and that will be phi naught plus k2. This implies phi naught by 3 plus k1 by 3, that is equal to phi naught plus k2. So from here, okay, so k2 will be equal to k1 by 3 minus 2 phi naught by 3. K2 is equal to k1 by 3. If you send this term here, it is minus 2 phi naught by 3. Clearly, you will say k2 is less than k1 by 3, or k1 is greater than 3k2. K1 is greater than 3k2. So k2 is less than k1 by 3, but they are giving the correct answer as k1 is less than k2 by 3. So obviously there is a typing error in the question. Considering typing error in the question, because obviously generally it will happen k1 lambda 1 together, k2 lambda 2 together, like that. Considering typing error in the question, k1 will have a pair with lambda 1 and k2 will have a pair with lambda 2. In that case, your correct answer will be, you will just interchange the k1 and k2. So k1 will be less than k2 by 3, or k2 will be greater than 3k1. So k1 will be less than k2 by 3, then we will be getting option B. I think there is some typing error required in this problem. Alright, but I hope the process which I wanted to teach you, you understood it and you are happy. You know what we have done, you are happy with it. What we have done is the basic maths of substitution, and we realized that there is a negative term on that side, which simply means LHS will be a bit lesser. If that would have been a positive term on that side, which means LHS term here would have been a bit higher in comparison to the RHS term. Alright, the basic maths. Let's move on to the next one. Next one is the work function of cesium and lithium metals are given to you. If we incident a light of wavelength 550 nanometer on these two metal surface, then photoelectric effect is possible only for. So let us check what will happen with 550 nanometers. 550 nanometers. So lambda incident here is 550 nanometer or 5500 angstrom. So energy incident in electron volt will be equal to 12400 by lambda in angstrom, 5500, like this. I think it can be cancelled, and it is 2.4. Okay, 2 point something electron volt, but it is definitely less than 2.5. है ना? 2 point something. Yeah, naturally it is less than 2.5 electron volt. So clearly energy incident is less than the work function of lithium and greater than the work function of cesium. So which will be satisfied? This implies this will show photoelectric effect and this will not show photoelectric effect. This one will show the photoelectric effect and one is not going to show the photoelectric effect there. Okay. I think you have understood. Let's move on. A subatomic particle of mass m is given to you, is given some velocity under the matter wave consideration. You are considering that de Broglie wave, matter wave will be associated with it. The particle will behave closely like. So first of all, you have to find out the de Broglie wavelength associated. Lambda d, that is h by mv. So h is 6.63 into 10 to the power minus 34. Mass is given to you as 10 to the power minus 30. And it is 2.21 into 10 to the power 6. Okay. So, okay. What else? Right. So, it will be 6.63 by 2.21, I think 3 into 10 to the power minus 30 will go there. It will become minus 34 plus 30. It is minus 4. Again minus 6 again. I think 3 into 10 to the power minus 10 meter. This 10 to the power minus 10 meter. If you remember a bit of the electromagnetic spectrum, 10 to the power minus 13 meter to 10 to the power, like 10 to the power minus 15 to 10 to the power minus 13, that is gamma. 10 to the power minus 13 to 10 to the power minus 10, that is X-rays. So this will correspond to X-rays, I believe. X-rays. You can even check the exact data from NCERT. I'm having a rough, giving a rough idea that it is belonging to the X-rays. And if you haven't got the idea of the wavelength range in the electromagnetic spectrum, NCERT is giving you a table. Production method, detection method, applications you must know. Out of the frequency range and wavelength range, my suggestion, my opinion, you can just remember the wavelength range. Frequency you can convert in the question to wavelength, then you can judge for the wavelength range. If you try to remember both, it might be a bit confusing. Better to remember wavelength range. Next is already a PYQ. An electron of mass m is given the velocity v0 I cap, enters an electric field. So there can be two ways of doing it. Logical way 1, visualization. It's an electron, negative charge, moving with v0 velocity in I cap. The electric field is existing in minus I cap. Electric field is existing like this. Being a negative charge, it will experience the force like this, opposite to the, being negative charge, it is experiencing the force opposite to the field. With the passage of time, you will realize if the force and velocity support each other, so speed should increase. Speed should increase means de Broglie wavelength should decrease with time. De Broglie wavelength decrease with time. Now if you check the options, it is same with time, unchanged. It is increasing with time. Okay, it is increasing with time. Here if it is multiplied with a quantity which is greater than 1, again it is increasing with time. If you see option 1, it is divided by a quantity which is greater than 1, so it is decreases with time. It is decreasing with time. So what you can say, only option 1 is telling you that. Option checking, only option 1 is that. Okay. Now let us talk about the exact value, like how we are getting it, exact value. Way 2, no option checking. I'll write lambda final will be equal to h by m v final. H by m, since field and force are constant, acceleration is constant, you can use the first equation of motion, u plus at. This implies lambda final will be equal to h by m, u is v0 plus acceleration is e0 by m into t. Alright, since you want to express your lambda final in terms of lambda initial, you must be taking this v0 outside. So it is h by m v0 and it is 1 plus, v0 was available in the first term. It was not available in the second term. So if you forcefully take something common, it is going to appear in the expression's denominator like this. Now this h by m v0, this term can be expressed as lambda initial. So lambda final will be equal to lambda naught by 1 plus e0 t by m v0. All-right. So you can do that by option checking as well as you can do that by proper deducing the expression. Okay. You can have a look. Let's move on. Next one. Nuclei. Now we have started with nuclei, atoms and nuclei. Okay. And then after this, the last problem will be problem collection will be of semiconductors. So the above is a plot of binding energy per nucleon against the nuclear mass A, B, C, D, E, F correspond to different nuclei. You have to consider 4 reactions and you have to see when the energy is released. Energy released means for energy to be released, Q value is positive. Q value is positive. Binding energy of product side is greater than binding energy of reactant side. Mass of reactant side is greater than mass of product side. There are no ideas regarding the coordinates, regarding the numbers, regarding the masses. So the only thing you can roughly comment about is the binding energy. Now you see, if A plus B is resulting into C, if A plus B is resulting into C, then definitely product side is more stable. If you say product side is more stable, this C is more stable. If more stable, stability is increased, this implies energy is released. Stability is increased, so energy is released. Check for the second one. Obviously, C was more stable, reactant side was more stable. If reactant side was more stable, you want to make it unstable, you have to supply some energy. It will absorb. With a similar logic, you check for D, like third and fourth part. If F is going to convert into D and D, then can I say this side again is more stable? Same story. Product side should be more stable. Product side should be more stable. So F resulting in D and D, again the product side is more stable. So energy will be released. So the correct options are option 1 and option 4. I mean, A option is correct. Reaction 1 and reaction 4 are resulting into energy release. Their opposite ones, second and third, will result into energy absorbed. Alright. Let's move on. The energy levels of an atom is shown in figure. Which one of these transitions will result in the emission of a photon whose wavelength is 124.1 nanometer? If this is the wavelength, can I say energy in electron volt that will be equal to 12400 by 1241 in angstrom. So answer is almost 10 electron volt. The 10 electron volt will have a transition gap from here to here, which means D line will result into the required one. Okay. From the given wavelength, you can comment about the energy. This is, remember, this is energy difference, delta E. From the given wavelength, you can comment about the energy difference, and then we have to check between which two energy levels you will get the energy difference. Okay. So yeah, for example, if I want to talk about A, it is going from 0 to 2.2. So the energy difference is 2.2. 0 to 5.2. So here the energy difference is 5.2. Here it is going from 2.2 to 5.2. So here basically it is 3. And 0 to 10, it is 10. So it's energy difference. You don't have to check for the value. You have to check for the difference in the value. Okay. Next. If an electron in a hydrogen atom jumps from the third orbit to the second orbit, and photon emitted is lambda, when it jumps from the fourth orbit to the third orbit, what will be the corresponding wavelength? So let me apply the Rydberg constant formula here. I will say that if it is moving from third orbit to second orbit, so 1 by lambda or nu bar is R. 1 by third orbit to second orbit means 1 by 2 square minus 1 by 3 square, and it is hydrogen atom. So it is 1 square. Even if it is hydrogen like, it is Z square, will be cancelled. Next time it is 1 by lambda dash, which you seek, which you want to find. That is equal to R, and it is moving from fourth orbit to third orbit. So that's 1 by 3 square minus 1 by 4 square, and it is 1 square. So we are supposed to divide it. The moment we will divide, denominator lambda dash will become the numerator. RR will be cancelled. In the numerator, we will have 1 by 4 minus 1 by 9 by 1 by 9 minus 1 by 16. So that can be written as 9 minus 4 is 5 by 4 into 9 by 16 minus 9 is 7 by 9 into 16. So I will say directly 9 and 9 will again get cancelled. Here R and R got cancelled, and 9 and 9 again got cancelled. This implies that will be equal to denominator 16 will go here. So 16 into 5 by 4 into 7. Again 16 into 5, 80 by 4, 20, and hence you get lambda dash by lambda as 20 by 7, or lambda dash will be equal to 20 by 7 lambda. I hope that's clear. Okay. Just the ratio things. Going for the next one. When a hydrogen atom emits a photon while going from n is equal to 5 to n equal to 1, its recoil speed is almost, it's a very important problem here. Very important. So I am explaining it from the fundamental. See, it's a hydrogen atom which is at rest initially. So now it will be, and this is an excited state, excited atom. Now it is a ground state atom which will be moving with a recoil velocity because of the emission of a photon. This photon is moving in this direction with the speed of light naturally. But we can conserve the linear momentum here. So while conserving the conservation of linear momentum, initial momentum is 0, final momentum has to be 0. So the momentum of atom, that is mass of atom into recoil velocity of atom, mv, that's how you write the momentum for a particle. But the momentum of the photon can be written as h by lambda, h by lambda, or basically E by C, like this. So from here they are asking you the recoil velocity of atom. Some good approximations will be required, but let us do it like this: 6.63 into 10 to the power minus 34. 1 by lambda can be written as our Rydberg constant, 1.097 into 10 to the power 7, and 1 by 1 square minus 1 by 5 square, and hydrogen atom, it's 1 square here. Moreover, mass which was in multiplication in the LHS will go into the denominator. Mass of hydrogen atom 1 AMU, 1.67 into 10 to the power minus 27. All right. It looks very complicated, calculative, but let us see. 1 minus 1 by 25, very interesting calculation here. 1 minus 1 by 25 is 24 by 25. 1 minus 1 by 25 is 24 by 25, slightly less than 1. And 1.097 is slightly greater than 1. Slightly greater than 1. Okay. So slightly less than 1, slightly greater than 1, product will be almost equal to 1, nearly. 10 to the power minus 27, and here minus 34 plus 7 is also minus 27. This and this is also cancelled. This is also compensated. So almost you got it as 6.63 by 1.67. 16 4 is 64 hota hai. So this is almost 4 meter per second. Almost 4 meter per second, and they are also asked nearly or almost. So approximations were required, hence the easy and smart approximation will result in 4 meter per second. You must take a screenshot of this. Alright, chaliye, let's move on to the next one. The de Broglie wavelength associated with the electron in the n equals to 4 level is, and you have to relate with different levels of ground state. You want to comment about de Broglie wavelength. Way 1 of commenting, lambda is equal to h by mv. Neither h will change nor m will change. This v is directly proportional to z by n. This implies denominator will become numerator. Lambda is directly proportional to n. So if you are in the fourth level, n is equal to 4 level, then you will be having the 4 times the de Broglie wavelength. 4 times the de Broglie wavelength of the electron in the ground state. Alright, way 2 of thinking about it. You can say, 2 pi r is equal to n lambda. The inception of, you can say, Bohr's quantization principle, starting of the Bohr's quantization principle. From here only we get mvr is equal to nh upon 2 pi, right? So 2 pi r is n by lambda. So here you can say 2 pi, this r is directly proportional to n square by z. So 1n single power will be cancelled, and lambda is directly proportional to n. Again the same thing. Okay. So de Broglie wavelength directly depends on the principal quantum number. Alright. That's what our learning is from here. Remember this property. Next is ratio of longest wavelengths. If we talk about the longest wavelengths here, lambda maximum, which means energy is minimum. Maximum lambda, longest lambda means energy minimum. Transitions are from adjacent states. if they ask the shortest wavelength means maximum energy. Maximum energy means transitions are supposed to be happening from infinity. Okay, so here what you can write, longest to Lyman and longest to Balmer. Longest to Lyman, longest to Balmer. Lambda max of Lyman by lambda max of Balmer. Remember in physics, or like we don't have a formula of lambda, we have a formula of 1 by lambda. So if you need the ratio of Lyman to Balmer, you should be writing it as 1 by lambda max of Balmer by 1 by lambda max of Lyman. Then only, in inverse form it will be R. Balmer means you are coming at 2, adjacent means you are coming from 3, and hydrogen atom it is anything, hydrogen like it is. And R, Lyman means you are coming at 1, adjacent means you are coming from 2. So R, Z square will be cancelled. So what we'll be having is 1 by 4 minus 1 by 9 by 1 minus 1 by 4, like this. So 1 by 4 minus 1 by 9 is 9 minus 4, that's 5 by 36, by 1 minus 1 by 4 is 3 by 4. 4 will cancel 36. 4 will cancel 36 at 9 times. 9 into 3, 27. I think the final answer should be 5 by 27. Please check the calculation also. This is the final answer for us. Okay. That's okay. Chaliye. Next one. A nucleus of uranium decays at rest to the nuclei of thorium and helium. So nucleus of uranium, parent nucleus is at rest, and that breaks into nucleus of thorium and helium. Okay, this is mass M, this is M1, this is M2. Suppose, assume that. So this is, say, parent is uranium, and basically uranium. Okay, so for the mass M1, if the momentum is P1 over here, and for mass M2, I'll write it separately. See, if mass M1 is moving with this P1, mass M2 is moving with P2, so you can say here the magnitude of P1 must be equal to P2. Kinetic energy is equal to P square by 2m, where P is going to be same for both. This implies kinetic energy is inversely proportional to m. And in this marathon itself, I have told several times that when you talk about inverse relation, then distribution is also in the inverse ratio. Means if someone is asking you the kinetic energy of particle 1 here, kinetic energy of particle 1, that has to be equal to total kinetic energy generated into opposite mass m2 by total mass m1 plus m2. Similarly, if someone is asking you Ke2, again you will write it in the inverse fashion because opposite ratio. So Ke2 opposite mass m1 by m1 plus m2. Always take the opposite mass, okay, because of this inverse relation. Fine. So anyways, this question talked about what? Who will have the higher momentum, who will have the higher kinetic energy, like that. So momentum must be same. And if we talk about the kinetic energy, here, as mass of helium is very, very less in comparison to mass of thorium, this implies kinetic energy of helium, lighter one, is very, very high in comparison to kinetic energy of thorium. Kinetic energy of helium is higher. Kinetic energy of helium is, mass is less, so kinetic energy of helium, the helium nucleus has more kinetic energy than the thorium nucleus. That's your answer. I want you to keep it with you, take a screenshot quickly, because that relation will be also useful in some other problems of the nuclei and basic mechanics problems. Alright, let's move on to the next one. Two nucleons are at a separation of this, the net force between them is F1 if both are neutrons, F2 if both are protons. So we know nuclear forces are charge independent. So in such a case, they are saying net force between them is F1 net force, because I think this is wrong. between protons for the net force, I'll tell you, nuclear forces order. Nuclear force order is charge independent, all of them will be same. So F1 is equal to F2 is equal to F3. F1 is between neutrons, NN. F2 is between protons, PP. And F3 is one of neutron and one is proton, NP. But if they are talking about the net force, then proton will also show some repulsion, right? Proton will also show some repulsion. So in that repulsion, I would say the F1 is equal to F3 attractive, but it will be less than F2 because F2 will be between proton repulsion also. In fact, F2 will be lesser. Proton will show repulsion also 1 to 2%. So 97-98% they will be showing the attraction, but these are 100% attraction, neutron and neutron proton. So that will be the order. Okay. Chaliye, I hope you anyways know this. This is an NCERT one. So just you need to be sure in the given question that whether they are asking the net force or they are asking the nuclear force. Accordingly, your answers will change. Problem number 88, a nucleus with a mass number 240 breaks into two fragments and they are asking you the total gain in the binding energy in the process. Two fragments each of having the 120 each. Gain is always final minus initial. Gain in binding energy is equal to BE final minus BE initial. BE finally you have two fragments each of having 120 mass number and binding energy of each one is basically 8.5 minus initially you had one of 240 and binding energy of each one was 7.6. So 2 into 120, if I take 240 common, that will be 8.5 minus 7.6. 8.5 minus 7.6, that is 0.9. 240 into 0.9, answer is 216 mega electron volt. Remember, gain is always final minus initial, change is always final minus initial. I'll write it for you. Gain is always final minus initial, change is also always final minus initial, loss is always, loss or decrease is always initial minus final. Okay ji, very basic thing but have to be understood in the language. Okay, let's move ahead. 89, a nucleus of mass number 220, parent nucleus of mass number 220 which was at rest decays by alpha decay. Alpha particle 4 AMU will be moving like this and the energy released is this, and the daughter nucleus will be having, I think 216, 220 minus 4 will be moving like this. What they are asking you, the kinetic energy of the alpha particle. Few minutes back I told you, if they are writing kinetic energy of alpha particle, always distribute in the inverse ratio of mass. So that is equal to Ke total or Q value into, always take the opposite mass. Opposite mass is 216 by total mass of the system 220. Always take opposite mass. Always take opposite mass. Alright. Now you just have to solve it here. Ke total is how much? 5 mega electron volt. 5 mega electron volt. It is 216 by 220. So anyways, it is 16 5s are 80 and 21080 I think by 220. So if you cancel by 20, if you cancel by 20 it is 11 and 20 say if you cancel this is 54 mega electron volt. I think the given answer is correct. 54 by 11 mega electron volt. See na, 1010 is anyways cancelled. If you cancel by 2 it is 11. If you cancel by 2 it is 54. Okay, let's move on. Yes, last question of the nuclei, and after this the second most important chapter of our entire NEET syllabus, semiconductors, will start. Okay, conceptual questions are going to come from semiconductors also. Not so many numericals because numericals used to come from majorly the transistor part, which has been officially removed. Now this one, thermonuclear fusion reactions may become the source of unlimited power for mankind. This is obviously true. Why true? As energy released in fusion is very much higher in comparison to energy released in fission. But this is valid for per unit mass. Means we are actually referring to its calorific value. But see, examiner has played in the reason very smartly. A single fusion event, we already know this, sun and other stars, inexhaustible source of energy, fusion reactions are majorly responsible for that, right? But what examiner has done is, in order to explain that, it has smartly used the language, he has smartly used the language that a single fusion event involving isotopes produce more energy than energy from nuclear fission. That is false, because once we said that fusion generates more energy, that is valid for per unit mass, not for every atom, not per unit per atom, not per reaction. A single fusion event, I mean per reaction, you are actually dealing with 2 or 4 nucleons, whereas in case of uranium you are dealing with more than 200 nucleons at that time. Okay, so a single fission reaction may generate and generally generates more energy in comparison to a single fusion reaction. So reaction comparison, generally fission will liberate more. Per unit mass or a given per unit mass or a given sample, for a given size of the sample, I would say, then you will say fusion will release tremendously more energy. So here it was a very nice problem, because the reason triggers the students, a lot of students, to do mistake. I would say assertion is correct, but reason is incorrect. Assertion is correct, but reason is incorrect for us. Okay. Now let us start our discussion of semiconductors. The combination of gates shown below yields, when both the terminals of NAND gate and NOR gate, are short circuited, they will behave as NOT. NAND gate and NOR gate short circuited, they behave as NOT. Okay ji, they behave as NOT gate. So now here what you are supplying is A, so this will behave as NOT gate, and what you will get here is A bar. What you are supplying here is B. Yeah. So if both the terminals of NAND gate and NOR gate are short circuited, that is going to behave as NOT gate. Chaliye, let's move on to the next one. In the combination of the following gates, the output Y can be written in terms of A and B as, I'll just zoom it a bit more. All right, so that we can just provide the input in the diagram itself. So A is coming directly with a straight wire here, you can see. Okay, A is coming directly, but B is coming with a bar. Again, A is coming with a bar here in this arm, and B is coming directly. So what this upper AND and lower AND gate will do, they will do it A dot B bar, and here it will be A bar dot B. And then this is a normal OR gate. See, I am writing here the names. These are not, these are AND, and this is a OR gate. What OR gate will do? It will do plus, it will do OR operation. So Y will be equal to A dot B bar plus A bar dot B. A dot B bar plus A bar dot B. Normal Boolean algebra. Logic gates, use of Boolean algebra. Alright, let's move on to the next one. The output of the given circuit in the figure. They are asking you the output here, and they are also asking when it will be available, positive half or negative half. See, first of all, there is no terminal given, A, B, nothing is given as such, I think. And here there is no use of A also. So in order to avoid your confusion, let me erase that. Okay, there is no A hereafter. Now, it's a single diode. If it's a single diode, so single diode can behave as half wave rectifier or a full wave rectifier. half wave. Two diodes complementary to each other, full wave rectifier, a single diode is a half wave rectifier, right? So in this half wave rectifier, if we conventionally go, like we study phasors, we study the rotation, you know, anti-clockwise should be taken as positive and clockwise should be taken as negative. So I'll use a different color to explain that. Suppose I am showing anti-clockwise, positive cycle, anti-clockwise. Anti-clockwise, the current is trying to move from N to P, a reverse bias. The diode will not conduct. The diode will not conduct. No conduction. Because if nothing is mentioned regarding the diode, we are supposed to take it as ideal diode. Ideal diode conducts or behaves as short circuit in forward bias, doesn't conduct or behave as open circuit in reverse bias. And if we talk about clockwise, can be taken as negative. Clockwise can be taken as negative. So diode will be forward biased, will conduct. So we will get the output only in half cycle, means behaving as half wave rectifier, but that too in which half cycle? Negative half cycles. So would be like a half wave rectifier with negative half cycles. This option is correct. Alright, very important problem. Remember, if the rotation, if the direction of current flow is not given to you, conventionally we are supposed to take it as anti-clockwise positive, clockwise negative. Next, in the circuit shown here, assuming threshold voltage of diode is negligibly small, then voltage VAB, see this time they are giving voltage VAB, they are giving you voltage VAB. Voltage VAB means they are asking you VA minus VB, VA minus VB. Now you see that carefully, for this diode to conduct, can I say here, for diode to conduct, current must flow anti-clockwise. Current must be flowing anti-clockwise, because if you flow anti-clockwise, then only it will be forward bias now. If it is flowing anti-clockwise, this implies, according to the potential difference across the resistor, VB must be greater than VA. VB must be greater than VA because the current is flowing like this, higher to lower. But they are asking you VA minus VB. So VA minus VB must be negative. Yeah, for diode to conduct, it must be forward biased. In order to be forward biased, the current in the circuit must be anti-clockwise. For the current to be anti-clockwise, according to the direction of current through resistor, VB must be higher than VA. But what they are asking you in the question, VA minus VB. In the last question, they didn't tell which is A, which is B. So we use the convention. In this question, they have given VA minus VB is required and we have commented about VB is greater than VA. So definitely this answer is negative. And since only one diode is there, it is going to behave as half wave rectifier. So we will be searching for a half wave rectifier and having the negative cycles. This is your answer. It is having positive cycle and it will be 0 at all times, no, and it will be the complete AC available without any diode. Okay, so the correct option is 4. I hope these two problems are back to back clear for us. Next is, few statements are given to you and you have to choose. I think you have to choose the correct one. Choose the correct statement. Correct ones. Okay. Now, first of all, the junction area of solar cell is made very narrow. Wrong. False. What do you want in solar cell? You want in solar cell that a lot of radiation should come, should do good bond breaking and should induce a good polarity. Then only you can use it as a cell, no? So for that matter, you should be having a broader one, not the lesser one. So it is a false one. Solar cells are not connected with any external bias. True. LED is made of lightly doped PN junction diode. False. Why, sir? Because we need a good amount of light emitting diode. If we need a good amount of light, we need a good amount of current. So good amount of current will be in lesser doped or highly doped? Naturally highly doped. So when they say lightly doped, it is false. Okay. Increase of forward current result in continuous increase of LED light increase. Continuous increase. False. Why, sir? Because if you increase the current, light intensity will increase, but beyond a certain value, even if you keep increasing the current, light intensity will not increase. In fact, I would say it will start decreasing a bit, but it will not increase. Okay, because of the resistance variation there. Negative resistance is, that those ranges we don't have to talk about, but do remember it is not continuously increasing, okay, forever. LEDs have to be connected in forward bias for emission of light, that is true. So the correct option for us is B and E only, B and E only. Alright, as I mentioned that lesser number of numericals are expected from semiconductors now, more conceptual theoretical questions are expected, and 3 to 4 problems. 3 problems are for sure expected in NEET exam. Next is, which one of the following represents forward bias? We can just check. I'll brief you regarding the forward bias and reverse bias. Forward bias means the p-type is connected to higher, n-type is connected to lower. P-type is connected to higher, n-type is connected to lower. That is, example, p-type is connected to positive, n-type is connected to negative, or p-type is connected to positive, n-type is earthed, or p-type is earthed and n-type polarity is intact, negative. This is all about forward bias. If we talk about reverse bias, we will say p-type must be connected to lower, n-type must be connected to higher. Means p-type is connected to positive, p-type is connected to negative, n-type is connected to positive, or p-type remains connected to negative and n-type is earthed, or p-type is earthed and n-type is intact, positive. So what I am doing is, I am always connecting for forward bias, p-type to be at higher, n-type to be at lower. So what they are asking is forward biased. P-type must be connected to higher, n-type must be connected to lower. I think you can check. Okay. So which of the following represents? So p-type is 3 volt. Out of this we have V lower. 0 volt is obviously higher than -2. -4 is lower than -3, and -2 is lower than -3. So we are interested in higher, option 2. All right, clear now? Next, 97. The correct Boolean operation represented by the circuit diagram drawn is. Before we talk about this problem, I'll take it as an opportunity to brief you regarding the switches and the behavior. See, if the switches are in parallel, and the bulb is normally connected means sequentially connected, this is called OR gate. This will behave as OR gate. If the switches are in series and the bulb is also sequentially connected, this will be the behavior of AND gate. If the bulb and switches are in parallel, this is the NOT gate. Bulb and switches are in parallel, NOT gate. Now, if the switches are in parallel, which means OR behavior, the bulb is also in parallel, which means NOT behavior. OR behavior along with NOT behavior is basically a NOR behavior. Similarly, if the switches are in series, AND behavior, but the bulb is in parallel, NOT behavior, AND behavior along with the NOT behavior is NAND behavior. So what do we have here? The switches are in series. If the switches are in series, AND behavior, and the bulb arm is in parallel with the switch arm, NOT behavior. The bulb arm is in parallel with the switch arm, NOT behavior, and hence the answer is NAND gate. NAND gate. Make sure you take a screenshot of this. All the switches bulb behavior correspond to which gate? Everything is in front of you. Alright, let's move on. The figure shows a logic circuit with 2 inputs A and B and the output C. The voltage waveforms are given and the logic circuit is. So I'll talk about several intervals that on which input what you are getting. So first interval, if you see, A and B both are 0, the C is also 0. On this interval, 0, 0, will result in 0. So either, like, the options are 0 0 pe if you get 0, the options are OR gate or the options are AND gate. To distinguish between them, these can be differentiated. Because NOR gate and NAND gate will give 1 at 0 0. So these can be distinguished in 0, 1 or 1, 0. When 1 is 0 and 1 is 1. So search for this interval. See, second interval. A is 1 and B is 0. A is 1 and B is 0. If A is 1 and B is 0, you are getting it as 1. Which means which gate? OR gate. And hence the correct answer is here, OR gate. You can even verify for other ones. Let us verify for this, this interval. So A you have 0 and B you have 1. A you have 0, B you have 1. Let's check the output. You again have 1. Again the same thing, OR gate. Alright. Understood now? Chaliye. When a PN junction is reverse biased, a very important problem that will give you some more clarity regarding the currents which are flowing during the forward bias and reverse bias. When a PN junction is reverse biased, the current becomes almost constant. I want you to know that reverse bias mein the only current is drift current. Reverse bias current is drift current only, and that is equal to 25 microamperes. 25 microamperes. When it is forward biased at 200 millivolt, a current of 75 microampere is flowing. I forward biased, which is equal to I diffusion minus I drift, that is equal to 75 microamperes. Okay. Find the magnitude of diffusion current when the diode is unbiased. A part, unbiased condition. I unbiased, which is equal to I diffusion minus I drift, is equal to 0 amperes. Why 0 amperes, sir? Because under unbiased condition, no biasing, no conduction is happening in real time. Na? If you connect an external battery, then only there will be a conduction observed. And I drift almost remains constant as 25 microampere. So from here, the diffusion current, because that must be equal and opposite, in case of unbiased, that must be equal to almost 25 microamperes. 25 microamperes. B part, they are saying reverse bias. B part, reverse bias. In reverse bias, you only have drift current. In reverse bias, you only have drift current. So I would say from here, you can conclude I diffusion. There is no drift current in, there is no diffusion current in reverse bias. There is no diffusion current in reverse bias, that is 0. And if we talk about the C part, that is forward biased. So I forward biased, which is equal to diffusion, which is required, minus I drift, which is again almost equal to 25, that will be equal to 75. So from here, I diffusion in case of forward biased, that is 100 microamperes. 100 microamperes. So the correct option is in the sequence 25, 0 and 100. 25, 0 and 100. Yeah, fourth option, 25, 0 and 100. Alright. I hope the properties are clear. In reverse bias, only drift current will flow, no diffusion current. In unbiased condition, diffusion and drift both will flow, but both will be equal and opposite. And in forward bias, diffusion and drift both will flow, but diffusion will be much, much higher. And drift current is almost constant in all the cases of biasing, forward, reverse and unbiased. Alright. The last question for our marathon. And with this, we'll put a nice closure on our marathon of 11th and 12th, both classes, 100 problems of both the classes which are targeting, which are the most probable problems for targeting this year NEET exam. Alright. So make sure you go through all problem models, you revise everything very nicely. Let us see here, last question it is. Refer to the circuit diagram given in the figure, which of the following observation are correct? You have to comment about total resistance, current, potential difference, this, that. Let me draw the circuit in front of you once again. So this is ammeter, which will measure the total current. This is 6 volts. And here it is point D. This is point C. There is a resistance here. How much? 4 ohms. And there is another resistance here, 4 ohms. And here, this is ammeter. Sorry, this is point A. Ammeter is there only. And this is point B, and it is 4 ohm. Now, if you want to see, like the P type is connected to higher potential and N type is connected to lower potential according to the external battery. So definitely it is going to behave as forward biased. If it is going to behave as forward biased, you can replace it with a straight wire short circuiting condition. These are parallel. If these are parallel, answer will be 2 ohms of this arm. This 2 ohm and this 4 ohm is in series. This 2 ohm and this 4 ohm is in series. So the R net is equal to 4 plus 2, that is equal to 6 ohms. If that is so, the current reading here will be equal to 6 volts by 6 ohms, and that is equal to 1 amperes. So it's another nice problem, which is a combination of semiconductor properties, semiconductor diode properties, as well as current electricity. 2024 also, you got that Wheatstone bridge along with the diode. 2025, there will be no surprise if you get similar or exactly the same problem. Okay. So that is 1 ampere there. Now what they are asking is total resistance of the circuit is 6 ohms. See, you calculated it, 6 ohms. Current in the ammeter is 1 ampere. Perfect. Potential difference across AB. So can I write separately here that this VCD will be equal to total potential 6 volts into same resistance. Same resistance is 4 by sum of them 4 plus 2. 4 plus 2, 4 plus the equivalent of this is 2. So that is equal to 4 volts. And here you can say, or otherwise also you can say VCD is equal to I into R. VCD is equal to IR, 1 ampere into 4 ohms. That way, either you do voltage division or you directly apply the Ohm's law, you will get 4 volts. And here naturally the VAB value parallel will be equal to 6 minus 4 volts. So that is equal to 2 volts. Now see what they are asking here. Potential drop across VAB is 4 volt. Across VAB is not 4 volt. Potential drop across CD is 4 volt. Actually VAB is coming out as 2 volts. Okay. Total resistance is 8 ohms. So the correct options are, you have to choose correct. Okay. I also told you, emphasize whether they are asking the correct or false. So the correct ones is A, B and D. So correct ones is A, B and D. Alright. So finally, we have successfully completed our 100 problems, must do problems marathon. Today, I hope you had a learning experience. If you have, attended it live, then we have already learnt a lot. If you are viewing this session in the recorded format, make sure you adjust your speed according to your own pace of learning, and also share it with your friends. There will be no surprise if you get a lot of problems from these 2 marathons. So make sure, if we have invested that time, we have selected the problems for you, you also make sure to do them very nicely. Anyways, you have to do some practice for the next 10 days before the NEET exam. So why not to practice this type of problems? Alright. So thank you so much for attending. Make sure you join the Telegram group and download the notes, which will be available in the description of the video. In that group only, we keep sharing the important materials for the exam, and for sure like, share and subscribe. All the best, bye bye, and wish you all the good luck for your preparation. Performance will surely be better.